Alexis, we're rolling.
Glad
I'm
to be here.
fascinated with this whole like light health mitochondria rabbit hole that I've fallen down since Jack came on here. And I love your glasses and I love your shirt. Make mitochondria great again. Show it off.
Let's go.
That's beautiful.
It's always a big hit.
How did you get interested in this? And like for people that aren't aware of you, can you just like lay out like who you are and your background in health and medicine?
Yeah, sure. So I got my PhD at Princeton. I graduated in December 2021. I was there for 5.5 years. Before that, I did my bachelor's in biochemistry and math at a small school in Lehigh Valley called Moravian College. Before that, I was actually in culinary school, and I ended up pivoting into science after a pretty crazy LSD experience that I had. It was like my first psychedelic experience.
LSD experience?
Yeah, I was like 18.
Steve, timer. Sorry, he forgot to do the timer.
Oh, okay.
You're good.
I thought you were saying like edit it out.
No. No,
But anyways, that was like a very eye-opening experience. Just like the nature of reality made me really question things because, like, for example, during that experience, I saw like the complementary colors really strongly. So everything was like red and green and purple and yellow. So whatever LSD I took at that time, it was really working on my my photoreceptors and my retina. I don't know why. I never had that experience after that, but it was just very intriguing. I was like, this is awesome. I want to learn more. And I also had that experience at Moravian when I was visiting my best friend there. And so it really just gave me a good vibe to the school. And so I was like, I'm going to transfer there. And I ended up kind of having a knack for chemistry. So I went down chemistry route, but then I really liked biochem because of the applications. And I should mention that before this, like 3 years prior to this, I lost 100 pounds and had like this huge weight loss journey and like health transformation.
Oh, wow.
So that was also a motivating factor in kind of pursuing biochemistry and understanding the body more. But even at that point, I didn't have an idea about career. Like I didn't know what I wanted to do. I kind of just always followed whatever felt interesting to me or curious about. So I did that whole thing at Moravian. I actually only ended up going to Princeton because it was like a commutable distance for me, and I figured it was probably a good school. I could defer my student loans more, so I was like, yeah, we're going. And I got accepted.
That's like a big time school, right?
Yeah, it's huge. But like you'll learn this about me throughout the conversation probably, but I have no like appeal to authority. I don't respect anybody just because they're supposed to be an expert or whatever, or an institution because it's supposed to be good. I always kind of saw through that because I had a lot of health issues as a kid. And so I really saw through like the standard medical approach, let's say, from a very young age, like starting at like 2 years old, just basically from like medical abuse and just constant failure of the system. I had like chronic recurring strep throat and was on antibiotics for months when I was like in first grade. And just kept getting worse and worse.
What did you say? What kind of strep throat?
Like chronic recurring strep.
Okay.
It just kept coming back, and nobody was asking like why it's happening. They just kept drugging it. And that's also when like the childhood obesity started too, right after the antibiotics. And now we know that like early childhood antibiotic exposure can create issues with obesity like later in life usually, but it happened pretty rapidly for me. I also think I had quite a bit of black mold in my childhood home. There may have been issues with the electrical wiring as well. Now I'm reflecting on that given what I'm interested in as well, like at this point. But all this kind of conspired together to create this health crisis for me. By the time I was junior year in high school, I was like 270 pounds. And joined a gym and started counting calories. I was still eating a lot of processed foods at the time because it was easy to count calories with them. And so I lost a bunch of weight, but at the same time, I also got an eating disorder right after that, bulimia, and then also developed IBS shortly thereafter when I was working actually shift work, which we can talk about the damages of that. But I was working shift work at a chemical company, internship at night, and then I was going to school during the day at Moravian. I was going to the gym. I was sleeping like 4 hours a day in like the afternoon. And that's when the IBS started. I was also crushing Rockstar, like the sugar-free Rockstar energy drinks. And I was like, why is this happening to me? And the doctors were like, we'll put you on an immunotherapy. And I'm like, no, I'm not doing that, first of all. But second of all, like there must be a reason why this is happening. It's like I didn't always have IBS. And so I started doing some investigating, cut out the stimulants, and cut also dairy out of my diet and found there was a huge trigger for me. And basically all my symptoms went away overnight. And so I basically didn't eat dairy for a good 5 years, like not even butter, like very strict. And during this time I was also at Princeton, and I came across Joel Green's work. He wrote the Immunity Code. I don't know if you're familiar with that.
No, I'm not.
But he's a very microbiome-centric, like citizen scientist, let's say. And so that put me down the microbiome rabbit hole. And up until April of 2023, when I found Jack's work, I thought like the microbiome was the thing that nobody was talking about, that was the most important thing. But all of that kind of changed. So to backtrack a little bit, I graduated in 2021 in December, like I said, from Princeton. Started my business almost right away, working with clients one-on-one, also teaching courses basically to help people be empowered with health information. I was very microbiome focused at the time, like I said. And then I went back for a postdoc at University of Pennsylvania in 2023.
Postdoc.
Yes, which is like the typical route. If you go into academia, it's like PhD, then postdoc, and then you'll go and you'll become a professor and like have your own lab.
Okay.
I never really planned on doing that, but I was like, I'll do a postdoc because it's like stable income, interesting projects. I had a good connection with the PI at Penn, and I was working on a tech development project, essentially looking at some multi-omics imaging of tissues, looking at mRNA and metabolites within like tumors, for example, and other types of tissues, and looking and seeing basically if we can correlate those with different disease phenotypes and health outcomes, and then we can basically use that to better treat patients ultimately in the clinic from cancer, for example. But, even at that point, I'm still like, okay, from a curiosity perspective, it makes sense to do this and it's interesting, but we're still not dealing with the root issues of like what's driving cancer to begin with. And it was during this time, so April 2023, that I found Jack through the Rick Rubin Huberman podcast.
That was one of the most mind-bending podcasts I've ever listened to.
My entire life changed overnight.
My world flipped upside down listening to that.
Yes. And I mean, imagine being me. I was in academia for 10 years. This somehow it never was on my radar. I knew about circadian biology from like Sachin Panda's work, and I thought that's interesting. And I just didn't get the sense that it was that important, though.
Yeah.
But the way that Jack lays it out, it's like, holy shit, like this is the most important thing nobody's talking about. I completely changed my own behaviors overnight, saw dramatic changes in like my sleep patterns. I always identify as a night owl. Suddenly I'm waking up early, I'm going to bed early, I'm getting tired, I'm sleeping through the night without waking up. I have better mood, better energy. I like clean my entire house within just like a week of making these changes. And I had like a lot of resistance around doing that. I think it was like, well, I lost my mom also the same month that I graduated from school. And so that's also a whole nother story with regards to the corruption in the medical system. But I just had like some resistance around going through that old stuff, and finally had like the momentum and like the fortitude to be able to do it. And then I started teaching my clients about this stuff, and they started getting amazing results too. And then I started teaching classes around it because I'm like, this information needs to get out ASAP. Everybody needs this because we're having a medical crisis and nobody is talking about this as like the foundational aspect to health, and in particular mitochondrial function.
Yeah, Jack's an interesting guy. I've been trying to like wrap my head around how the way he communicates can be very overbearing, and he's got kind of like a cult of personality where he's obviously super intelligent. The guy's got a very well-oiled brain up there, and there's a touch of narcissism, and he's an alpha male personality. So it's like whatever he says, it sounds so believable. Like it's like, even like, I don't know anything about this shit. So I don't know how right or how wrong he is about anything he says, but everything it's the way he communicates. It's like, bro, my friend, let me tell you something. Let me ask you this, Alexis.
I freaking love him.
It's so compelling the way he communicates.
He's a great storyteller too.
Incredible storyteller.
Yes. Well, that was the thing, actually, when I found his work. Of course, I'm stunned at the information, and then I immediately go down the rabbit hole looking through the literature and finding out that it was all true, much to my shock, because I'm like, how did I never know this?
Yeah.
Yeah.
The one thing where I was like, are there any medical data or studies or research to prove this, where he was talking about, I read his article that he posted on his Patreon about babies in utero, where he was talking about how when the fetus is developing in the womb, somehow the woman's body creates blue light to stunt the development of the brain so that the cranium can fit through the birth canal.
Yeah, so actually, I had Scott Zimmerman on my podcast, who's the founder of Nira Lighting. He makes light bulbs that are actually healthy. And we talked about this on my podcast, Undoctrinate Yourself, where basically it's really interesting. But as the pregnancy progresses, of course, in the beginning, the belly stays pretty flat. And there's a lot of fat tissue and like abdominal muscles that's preventing light from actually penetrating in. But as the pregnancy progresses, like you enter the third trimester, now you're starting to get this protrusion that's actually stretching the muscles and the skin to make it thinner. And what that means is there's more light coming in from the outside now, which would include some of the shorter wavelength light as well, like blue light. Not necessarily UV light because it's very short wavelength, but blue light, if you stretch that skin taut enough, you can get some through, and that can directly work on leptin. That can begin to essentially allow the baby to put on more fat because it needs that fat for when it's born so that it can maintain its body temperature.
So would it not be good if you're like pregnant with a child to be in the sunlight? You don't want to be in the sunlight because you don't want to grow the baby any bigger?
No, it's great. It's self-regulating mechanism. Yeah. Exactly. Because, well, also sunlight is perfectly balanced. We never receive blue light in isolation in nature. So like if you look at standard LEDs and fluorescent bulbs, device screens, it's a big bolus of blue light and it has basically no red or infrared light because it's energy, like energy saving or whatever, energy efficient. But the problem with that is that in nature, most of the light we get from nature is in the form of the sunlight. And sunlight has about 25% blue light midday, but it has over 50% red and infrared light. And that red and infrared light has very balancing effects on the blue. So blue light in isolation is known to inhibit mitochondrial function on the surfaces, on your skin, eyes, and proximal brain regions. But red light and infrared light actually have the opposite effects. When red and infrared light interact with mitochondria, it actually stimulates mitochondrial energy production, water production, and overall function. And so in nature, obviously it makes perfect sense that we would, if we're going to receive blue light, we're going to receive also a balance of red and infrared light to help counteract some of those inhibitory effects on mitochondria. But in the indoor, unnatural environments with artificial light, we're not getting any of that because we block near-infrared light at every turn. All of our window glass is coated to prevent that from entering because it's heat. Near-infrared light is heat. Infrared light in general is heat, and that heat is seen as energy inefficient because we're looking to like keep our rooms at a certain temperature, right? And so we don't want outside temperatures influencing the inside because it will drive up energy costs. Not realizing that near-infrared light is actually an essential nutrient for the human body. It's not just superfluous. Our mitochondria actually require it. And if you're one of our ancestors living a more outdoor lifestyle, even just before like the late 1800s when like the power grid started getting rolled out, most of the light we were getting was from firelight or the sun. And firelight is primarily like orange, red, and mostly infrared light. It's mostly heat. It gives off a lot of warmth. That's why you feel that. That's non-visible infrared light. So if we're in that environment, let's say even late 1800s and before, we're getting a ton of near-infrared light from flame and also from the sun, which of course from sun up to sundown is very enriched in this long wavelength red and infrared light. That's why the sunrise looks red, sunset looks red. That is consistent throughout the day. What really changes is the short wavelength.
Atmosphere.
Yeah, exactly. So the short wavelength light can't really pass through the atmosphere at like that very like long angle. But as the sun goes towards solar noon, then the thickness of the atmosphere becomes less, and then you can get more blue and UV light coming through. And so that's why the blue and UV really peaks around midday, and then it goes back to basically just being red and infrared at night. And so even if you're sitting in the shade outside, green plants reflect a ton of near-infrared light. They do not absorb near-infrared light. It's reflected off. And so even if you're sitting in the shade, you're receiving a bunch. And it penetrates.
Oh, really?
Yeah, and it penetrates into your body all the way through. If you're standing outside and it's reflecting off the green plants from all directions, it is going into every organ and tissue and it's stimulating your mitochondria.
What about if it's overcast like it was this morning?
Even if it's overcast.
Really?
Yep, because long wavelength light it can penetrate through basically anything. Obviously, there's some materials that are super thick, but clouds, that's nothing to that light.
Wow.
Yeah.
It seems like you have, for somebody who spent so much time in college, got a PhD and was essentially like a part of a huge institution. You seem like quite the rebel. You have a very rebellious spirit about you. Is that pretty rare in your field and
I don't
in
know
your
anybody
world?
like me.
Yeah, there's not many people. There's not many people like that, right?
There's not. I mean, most people want to be in the
happen?
rat race. Like I said, I've always been this way. Like I always had a defiance for authority. I would even go as far as saying that. Like I would always like to be like the thorn in somebody's side, asking the more difficult questions or like the inconvenient questions.
Right.
And so that kind of always just carried on. And I just consider myself a curious person. Other people would see it as defiance, but like I just want to know stuff. Yeah. I just want to know what's true and like what makes sense. And if it doesn't make sense, I'm going to say something. And the mainstream narrative doesn't make sense.
Typical people who went through school the same way you did or studied the same things as you do, what sort of careers do they end up having? Yeah,
so I mean, if you go get your PhD, you're basically either going into pharma, biotech, or you're going to become a professor and have your own lab.
Got it.
And whatever those roots are, they're all the pharmaceutical military industrial complex.
So you don't want to ruffle any feathers.
You never want to ruffle feathers because then you can't get funding or you can't get a position. And there's also, I would say, like nepotism in a certain sense where it's like you want to get in good with certain people. And then, you know, you have those connections that allow you to go up the ladder. You have to play the game in order to get ahead.
Yep.
Yeah.
Just like any big institution.
Totally.
The industrial military complex, not the military industrial complex. Fall is already happening, and I can guarantee you won't catch me sipping on a pumpkin spice latte covered in whipped cream and pretending to be jolly. I'm embracing the natural power of legal cannabis this fall with Via. If you haven't heard, Via is very well known for their award-winning hemp-based gummies, vapes, topicals, and calming drops. I've been taking their gummies, and I love them so much, I've been giving them away. My personal preference is to take a quarter of a full square and then take another quarter, maybe like one before dinner, one before bed, because it's just a super calming effect. And if I want to get creative or if I want to watch a movie and relax with my wife, it is the perfect amount of THC to get you right in the pocket. Via's hemp extracts are perfect for relaxation and rejuvenation. Whether you want to ease anxiety, better your mood, or just get high, they have what you want. They range from 0 to 100 milligrams of THC, so you get a great tailored experience. And if you're not into THC, that's okay. Not all their products have it. Their CBD products are designed for sleep, focus, and energy too. They are experts in hemp extract and using it to get the effect you want naturally. And they have products in every price range. Via is farmed and crafted in the USA with AB tested and certified hemp, and they've won awards for their customer service. So if you're 21 or older, check out the link to Via in the description and use my code DANNY to get 15% off. After purchase, they ask you where you heard about them. You can support our show and tell them Danny Jones sent you. Again, click the link in the description and use the code DANNY, DANNY, to get 15% off. And remember, Danny Jones sent you. This fall, enhance your everyday with Via. Is that intentional? Does he say that intentionally like that? Or is that just dyslexia?
Well, it's actually funny because I don't know if you know anything about astrology, do you?
Yeah. A little bit.
So like he's an Aries stellium, which no surprise there. Like he has a bunch of Aries placements essentially, which Aries is like the cardinal fire sign. It's super passionate, fiery, intense. So Jack, right? But his Mercury is also in retrograde in his natal chart, his birth chart. And whenever Mercury's in retrograde, it tends to create like verbal dyslexia, like you can switch your words around.
Right.
It can create just like some muddling of thoughts and like it doesn't come out necessarily exactly right. But also I feel like we understand exactly what he means. I feel like that's not really affecting.
I was just curious. I just didn't know if he was saying it purposely like that to convey some other meaning or.
No, I don't think so.
No, yeah.
It's also funny because my partner also has Mercury retrograde and is also verbally like dyslexic. I've seen it so many times. Like I do people's charts. I'm like, oh, that makes sense.
Yeah, it's just something I can't get by sometimes. It just like stops me. I like completely breaks my train of thought. Like what? The industrial military complex. So you decided obviously against working, like maintaining the status quo or pursuing a career in the pharmaceutical industry. Did you ever like think about doing that at any point or?
So I dipped my toes in when I took a gap year after undergrad before going to Princeton. And during that gap year, I worked at Bristol Myers Squibb for like 10 months. And it was exactly what I expected it to be, basically. And it's actually pretty wild, but the people who were working there, they really thought they were doing good. Like, they thought they were saving lives every day, which is pretty shocking because, I mean, I could just immediately see, like, you're not curing or, like, you're just basically masking a symptom. You're prolonging an issue that could have been solved more acutely, actually, by just kind of covering up the symptomology. And especially with, like, immunotherapies, which are really popular in the cancer world now, it's like we're modulating the immune system, you know, to make it more reactive to cancer cells, but what else is it becoming more reactive to? Like, what else are we doing there? And with the autoimmune drugs, like, we're using a lot of immunosuppressants in that department. Well, the immune system is surveilling constantly for cancer cells. So if we're suppressing the immune system, you know, what are we going to create in 5, 10, 20 years for people? So there's just a lot of lack of looking at the long game, I would say, in the standard medical approach. We're very much focused on acute care and like getting people out of pain. And like, we just have this immense distaste for being just like uncomfortable in this society. Like, we just want to be feeling comfortable all the time. And it's like, actually pain is what accelerates growth, and it allows you to identify where there's some things you need to work on in your life. And if we're constantly numbing symptoms, we're missing the opportunity to deal with the issues at hand, really.
What do you think the primary reasons are for America, people in this country having such low health outcomes, or like such a crazy, explosive rate of obesity and cancer and all that stuff?
Yes, I mean, if you would have asked me that March of 2023, I would have said something about gut health and the microbiome and the food and exercise.
Nutrition.
And nutrition, exactly. But now I can really, really see that light and water and magnetism, like Jack talks about, are really this foundation of the health pyramid. Because let's say your light environment is really poor, like you're, living indoors all the time, you're wearing sunscreen when you go outside, you're wearing sunglasses, contacts, prescription lenses when you're out in the sun. You're hiding from the sun, and then you're also irradiating yourselves with LED lights, fluorescent lights, and your device screens. Well, that has knock-on effects to every other area of health. So for example, if you're in front of these blue light screens, that hijacks your dopamine system, that really burns out that system that's able to buffer you against compulsivity, let's say. And so if you're in front of screens all the time, you're going to crave more hyperpalatable foods, highly processed foods, because your dopamine system's constantly looking for another hit of something to keep it going. Same with the phones. Like those also like hijack that system and make you addicted to it.
Why does the blue light specifically hijack the dopamine system?
It's addicting to our system.
The blue light?
Yeah.
How so?
So when it interacts with the eye, there's these receptors called melanopsin. It's a blue light detector in the eye. That eye is directly connected to the master clock in the brain called the suprachiasmatic nucleus, or the SCN, via the RHT, or the retinohypothalamic tract. So the eye is directly connected to that part of the brain. That part of the brain is the master clock that tells every other cell in the body what time of day it is. But blue light is also directly stimulating dopamine, the dopaminergic neurons that gets you excited. I mean, I imagine evolutionarily speaking, during the daytime when blue light is at its highest, you need to be cognitively alert, you're awake, there's certain functions that correspond with the daytime when you're exposed to that blue light. However, the blue light that we're receiving now is not the same because, like I mentioned before, it's like this big bolus of blue light in isolation. We're not receiving those balancing effects of red infrared and also UV. So that blue light is not only hijacking those same awareness centers that get us into more of a sympathetic state, get us going and alert and like just more like mentally stimulated, but we're not also getting that balancing effect of like UV light, for example, which stimulates the production of this prohormone called proopiomelanocortin, or POM-C, in both the skin via UV light and also in the brain via the eyes. So POM-C is this really complex prohormone that's cleaved into 10 distinct hormonal products. 3 of those are alpha, beta, and gamma endorphins, the endogenous opioid molecules. So people think about endorphins and running, but the primary stimulus of endorphins, ancestrally speaking, is UVB light in particular. And so these endorphins, they not only reduce anxiety and depression and improve mood, they also improve cognition, learning, and memory. And they allow us to basically cruise at altitude dopamine-wise. So we're now, if we're receiving this like drug-like effect from UVB light exposure, now we're not going to be craving other things like processed foods or social media or other things that addict us to the sun. And then when you see that, it makes it perfect sense why we are addicted to the sun and why nature would want to do that, because it actually is, we're meant to be in it, right? Like, why would we make endorphins, these endogenous opioids, if we weren't meant to be in the sun?
Interesting.
Yeah. I mean, that's just a little sliver. We can talk about every wavelength of light and like how specifically, if we look at the modern system, we're constantly demonizing infrared and UV light. Like, we're not really demonizing infrared light. We're just blocking it by saying it's energy efficient or whatever. Not realizing that energy efficiency and technology is creating an energy crisis in the human body, because infrared and UV light are the most important frequencies of light for human biology. That's how our mitochondria run. Our mitochondria also make light. They make infrared and UV biophotons.
So I can see how the blue light from screens and technology and staying inside could affect the dopamine system, and how it can encourage people to stay inside and not give them basically any incentive to go outside or do anything like that. Like people work out in gyms inside. People rarely work out outside. Eating, it makes you eat, incentivizes you to eat more convenient, shittier foods. And I can see how that can lead to things like obesity or autoimmune disorders. But like, where specifically does cancer come into this?
Yeah, so cancer is fundamentally a mitochondrial disease, not necessarily in the way that like Dr. Seyfried will talk about, where it's like, mitochondrial dysfunction is at the root of cancer, but he's not getting the next step, which is like what drives mitochondrial health. That's where light, water, and magnetism come in, because mitochondria are essentially electromagnetic antennas. They're also electromagnetic emitters. So the mitochondria are sensing the electromagnetic environment, and they're also creating frequencies of light. Like I just had mentioned, they make infrared light, and that's why if you get an infrared camera, you can look at somebody on it and you can see them. They're emitting heat, which is infrared light. The mitochondria are also making UV biophotons. So our bodies are making their own UV light. And and there's literature on this.
There is?
Yeah. Fritz Popp is like the godfather of biophoton research. This was going back in like the 50s or even earlier. But even more so, like now, what's his name? Roland Van Wyck, Light Sculpts Life, that book. He talks about all the ways that light interacts with biology, mitochondria, and how our bodies are light-making machines. They're also light-sensing machines. And depending on what light is coming in and going out is dictating the health of the system. So we know, like, for example, if you get cold really stimulates mitochondria because you want to make essentially more heat to bolster your body temperature in response to the cold water immersion, for example. But when you do that, you're stimulating the production of all forms of light, including the UV light as well. And that's why Jack also talks about how if you want to build your internal melanin, like we have melanin deep in our brain, in the locus coeruleus and the substantia nigra. The substantia nigra is the part of the brain that becomes degraded in Parkinson's disease. It loses melanin over time, and melanin and dopamine, you might know that dopamine is like a defective in the Parkinson's disease, but melanin and dopamine are very tightly linked, where they both share the same precursor, tyrosine, which is an amino acid. And so what the body can essentially do is if dopamine is, let's say, running low, it can break down melanin to make L-DOPA and then shunt it into dopamine production. And melanin can be broken down also if there's a very oxidative environment. So if it's like you're under a lot of inflammatory stress, you're in, let's say, a poor light environment 24/7, you're eating bad foods, you're not moving your body, it creates a very reactive and oxidative environment that melanin can actually help to sequester some of those reactive species. But it's at a cost, because if you don't get out of that environment, now the melanin is actually being like terminally degraded and you're losing those sheets. And we have melanin not only in those parts of the brain, but also in the nasal mucosa, the oral mucosa, the inner ear. It's essentially at the barrier of every sense organ. Also in the back of the eye, the pigmented retinal epithelium. So the retina and in general, the body requires melanin to function optimally, especially as it relates to the sensory organs, including the sensory apparatus within the brain. Now, the mainstream dermatologist will tell you that there's no such thing as a healthy tan, which is insane, because if you learn about the functions of melanin, outside of everything I just said, melanin is also a really potent heavy metal chelator, can pull heavy metals out of the bloodstream. Melanin also is a really important bioenergetic molecule where it can split neighboring water molecules. When sunlight strikes melanin, it can split water into free electrons, molecular oxygen, and molecular hydrogen. Molecular hydrogen and oxygen can go and power mitochondria. The electrons, of course, also power mitochondria via the electron transport chain, which is what it facilitates ATP production and metabolic water production. So melanin ties in with the story, of course, about cancer, because if we're thinking about cancer, we're thinking about mitochondrial dysfunction, which is creating more reactive nitrogen and oxygen species that are leaking out into the environment. So whenever mitochondria become dysfunctional, the resting membrane potential drops. That's essentially because you're getting less flow of electrons through. So the membrane potential is a measure of like the electrical potential of the system, essentially. So when you're getting a flow of electrons, that can increase the membrane potential. But if you start to accumulate, let's say, mutations within the mitochondrial DNA, those mutations directly impair mitochondrial function, because the proteins that are responsible for shuttling those electrons along the ATC are encoded by those genes. So whenever you accumulate what's called heteroplasmy, and the godfather of this research is Dr. Doug Wallace out of Children's Hospital of Philadelphia. He's still there. Actually, I'm dying to interview him. He's the one who discovered that you inherit all your mitochondria from your mom.
Wow.
Yeah. And there's major implications for that as well, because let's say your mom's not living such a healthy lifestyle. Now you're dealt a hand of mitochondria as a baby that are suboptimal. And depending on how those mitochondria kind of sequester into different tissues as you're developing, some tissues might be more burdened with poor mitochondria than others. And that's where the implications for like energy production come in, because if you have these mutations and you can acquire them yourself as well through living an improper, like an unhealthy lifestyle with regards to light and food and movement and all that, now your energy production is down, which means your resting membrane potential drops, which means now the reactive oxygen and nitrogen species that are supposed to stay within the mitochondrial environment start to leak out because that membrane potential is what actually helps to keep them present. And that actually links into the magnetism part of the story because, I don't know if you know this, but whenever there's like an electric field, a magnetic field forms at 90-degree angle to the electric field. It's like physics 101. So when you're getting healthy flow of electrons through the electron transport chain, you have your electricity, you have your magnetism forming a 90-degree angle. And that magnetism is actually what pulls oxygen towards the electron transport chain because oxygen is paramagnetic, which means that oxygen is attracted to magnetic fields. So when you have healthy electron flow, it creates a magnetic field 90-degree angle, the oxygen is pulled, and the oxygen serves as the terminal electron acceptor to the ETC, that's why you need to breathe oxygen, essentially, because that oxygen is accepting those electrons, and as a result, water is being made, special type of metabolic water called deuterium-depleted water, which we can talk about in a little bit. And that's the hallmark of a healthy mitochondria. But if you start accumulating mutations, because you're living in a very reactive environment that's, not healthy by all the metrics that we've spoken about.
Every day, subtle changes occur in our bodies, often going unnoticed. It's called inflammaging, a chronic low-grade inflammation that affects our health as we get older. It's more than just a sign of aging. It's a key contributor to health issues like cardiovascular disease, dementia and depression, and physical decline. It continuously weakens our body's resilience, turning minor infections severe and impacting mental health and cognitive function. Inflammaging significantly diminishes both quality of life and independence. Proper diet, exercise, and sleep can only get you so far. This is why I take Clean Being by Verso every day. It contains ingredients targeted to fight off and help prevent inflammaging. Research shows that these ingredients clean out damaged cells in the body that affect healthy cells, reduce inflammation, protect against oxidative stress, and improve conditions like cardiovascular disease and neurological disorders. After taking Clean Being for some time, I've experienced a laundry list of benefits from less joint pain, more energy in the morning, better mood during the day, and I'm even sleeping better and have clearer skin. And these are all benefits of reducing inflammation. Plus, Verso ensures transparency and quality by publishing third-party testing results for each batch they produce, so you know you're getting exactly what you're paying for. Click the link below or head on over to ver.so/Danny to get 15% off your first order. Again, that's ver.so/DANNY for 15% off your first order. It's linked below. Now back to the show.
Now your membrane potential drops, those nitrogen and oxygen species start leaking out. That directly affects the nuclear genome because, as Dr. Doug Wallace has shown, mitochondrial heteroplasmy, the rates of mutations within mitochondria, that burden that we've just discussed, if that's high, that leads to actually changes in the epigenetics of the nuclear genome. So it basically can turn off the expression of some genes and turn on the expression of others. And it can also lead to mutations within the nuclear genome.
What do you mean when you say epigenetics?
So epigenetics being the expression patterns of genes. So there's two primary epigenetic modifications that can be made to modulate this: acetylation and methylation. Methylation, broadly speaking, will decrease the expression of a subset of genes, and acetylation will increase the expression of genes. And so in the field of genetics and cancer biology, let's say, there's a huge focus on the nuclear genome and just focusing on what mutations are driving cancer to be started and how can we target them and dope them to help to prevent cancer or to slow it down. Not realizing that that's actually not actually as far upstream as we need to go. We actually need to look at the mitochondria, which are driving the mutations to begin with. So that's where kind of the disconnect is in modern medicine, where there's this myopic focus on the nuclear genome and kind of just a broad ignorance around mitochondria and their role in regulating the nuclear genome, the development of mutations, changes in gene expression, which have major implications for not only cancer, but all of our other chronic diseases.
Is there any sort of process or protocol that someone can use once they've already got cancer to implement this stuff and reverse it? Or once you have a tumor, for example, is that pretty much too late?
No, I mean, so what I would say is that cancer is the ultimate sign from your body that something is wrong, right? Because that's one you can't ignore. There's lots of problems that you can ignore, little aches and pains, little signs that you can, drug them and ignore them. Cancer is no, fuck you, you need to pay attention to this. And so that's the ultimate sign that your mitochondria are really screwed up. You need to do something about it. So typically it takes extremes. And that's why Jack says, like, literally move to the tropics, because you need as much UV light as possible to turn off the nuclear genome, to stop gene expression there, to also support your mitochondria, because UV light and infrared light, very strong sun in the tropics, is what helps to support mitochondrial function. Like we mentioned, the infrared light directly stimulates mitochondria. The UV light and the infrared light both play important roles in structuring the waters of the body. So I mentioned earlier, deuterium-depleted water made of mitochondria. A lot of people, when they think of water, they think, oh, the water you drink. The water your body makes is very special and very different, and it's responsible for cellular hydration. So the water that you drink also can play a role in like blood hydration, and there's some interchange between the blood circulation, of course, and the cells. But the water your mitochondria make as deuterium-depleted water really helps to facilitate mitochondrial function. So as it turns out, deuterium is, I don't know if you know this, but it's like a heavy form of hydrogen. So there's different forms of hydrogen called isotopes. Light hydrogen, which is like the normal, most abundant type of hydrogen, is called protium, protons. And the heavier form is called deuterium. There's another form called tritium. It's radioactive, but it's not really a part of this conversation. Okay. So deuterium, because it has an extra neutron, has a neutron versus protium doesn't have a neutron. It's bigger, it's heavier, it's like it has a more size to it. And if you look at the electron transport chain, you can see that ATP synthase, which is at the last complex 5 essentially, which is what allows the battery to work. So if you look at a mitochondria, it's literally a battery. It separates negative charge from positive charge. The positive protons go into the intermembrane space, and then they basically go back into the inner matrix in complex 5. It's literally a rotor that spins as the protons come through.
Oh, okay.
Yeah, but the important part about that is that rotor can't work if deuterium's trying to come through because it's too big. It doesn't fit. It's very specific to protium. So mitochondria love protium. They hate deuterium. So they automatically like try to exclude deuterium.
How much deuterium is in normal water that we drink?
So it depends on your latitude. Around here, it's probably around 140 parts per million. Around the equator, it's probably closer to 155 parts per million. And if you go super north, like Iceland, let's say, that could be like around 125 to 130 parts per million.
So it's lower the higher you go?
Yep.
And that's better?
Well, if you're sick, it's better. You don't really have to worry about the deuterium content of your water if you have a very strong relationship with the sun and or with the seasons. If you live somewhere where it gets cold, and we'll talk about that, because essentially the problem is that we're constantly trying to subvert nature. So for example, I'm from New Jersey. During the wintertime, people bundle up and then they go inside and it's turned up to like 70, 75 degrees inside.
Right.
So it's like we're not getting the cold that actually compensates for the lack of UV light. In nature, whenever it's cold...
Oh, shit.
Yeah. So whenever it's cold, it's meant to be low UV light, which means when you get cold, it stimulates your mitochondria to make their own UV light.
Wow.
So it's like UV and infrared light are such essential nutrients that the body will make it itself. It will make it itself if you give it the right inputs.
That's crazy.
Yeah. Well, what's also crazy is that most people also, even if they live in a more southern latitude, like near the equator, if they're sitting inside all day, they're not getting the UV light that's associated with sitting at a warmer temperature. Like if you're sitting indoors around 70, 75 degrees, your body's like, okay, it's pretty warm. So you're kind of expecting some UV light, but it's not coming. And you're also not getting the infrared light, which is supposed to be bathing you constantly, regardless of the seasons.
Right.
So we're just creating this very artificial environment our body doesn't know how to interpret the information that's coming in because it's completely novel compared to even just 150 years ago.
Can you explain what's going on with people that are from northern latitudes, like Norway up there, and they have like super light blue eyes, and people from like equatorial latitudes, they're always dark brown eyes? Yeah,
I mean, this is a story about melanin, same as like melanation in the skin. So when you live near the equator, your body, most people will think about like, let's say centralized dermatologists, they'll say the skin has more melanin because it's protecting the body from UV light. That's not the whole story whatsoever. That melanin is actually productively using that UV light. Like I mentioned, when high quality, high UV index sunlight interacts with melanin in your skin, it can split water molecules and make free energy essentially for the cells. So that's a huge reservoir of potential to tap into. If you're biology, you want to leverage that energy coming from the sun. The UV light is very high energy wavelength of light. So you can leverage that to actually give your body free energy. And what we actually didn't talk about is that in addition to making the alpha, beta, and gamma endorphins, which work on the brain and mood and dopamine status, we also make alpha, beta, and gamma MSH, or melanocyte stimulating hormone, in response to UVB light in particular. So the melanocyte-stimulating hormones, as the name implies, stimulate the production of melanin in the skin and also in other parts of the body as well, like the deeper parts of the brain, etc. But in addition to that, they also directly work on the hypothalamus, in particular alpha MSH, to suppress appetite and increase energy expenditure. So the hypothalamus is the like thermostat of the body and the brain. And that, if you hear that phrase, like that statement, it should be like, wow, that's like a holy grail, and especially in weight loss, because if you want to lose weight and maintain healthy body composition, you want to have a lower appetite and a higher energy expenditure, right? Mm-hmm. And even I remember talking to my old boss at Penn, mentioning a bit about this story in the beginning when I was learning about it. And he was like, yeah, alpha MSH, like that's been a marker for obesity for years. Like it's been very highly associated, like low alpha MSH or modulations in that pathway is highly associated with obesity and metabolic syndrome. Mm-hmm. So our bodies are naturally supposed to make an abundance of alpha MSH as well as the beta and gamma in response to UV light. But there's been this demonization campaign that's been going on for decades about like stay out of the sun, slip, slop, the sunscreen and wear your sunglasses. And the ophthalmologists and the dermatologists are like, you know, if you go in UV light without protection, you're a dumbass essentially. Mm-hmm. And it just couldn't be farther from the truth, from just like a very basic, like we have the science to support it. We also have the first principles and like the ancestral perspective to view this from that says like, actually, you know, our ancestors were perfectly fine until, you know, we didn't start getting this chronic Neolithic disease until recently, like literally the 1900s. Mm-hmm. Even in the early 1900s, Jack talks about all the time, like certain cancer cases, lung cancers and other types of cancers were like so rare that, you know, people were like, you know, you'll never see this again. So the residents will come in and they'll see the surgery get done because like this is like a once in a lifetime situation. And now like 1 in 4 people or even 1 in 2 people are getting different types of cancers depending on which cancer you're talking about. And it's clearly an epiphenomenon of our modern circumstances, our modern way of life. So it seems like the onus or the burden should be on the centralized model to prove their perspective, but instead it's like, we're just going to tell people this is the case. They're not going to question it because we've MK Ultra'd them and now they're compliant and blue light toxic and, you know, they're just going to listen to whatever we say. And it's ultimately lining the pockets, of course, because if you were able to like heal your own diseases or avoid them altogether through leveraging, let's say, nature and a healthy diet and moving your body outside, then, you know, you don't really need that system anymore. So, I mean, not to be completely conspiratorial, but it feels like this is the right place to talk about this stuff anyways.
It is. So, okay, then why does the sun damage our skin and give us skin cancer and melanoma if the sun's so good for us? Alexis,
well, I'm glad you asked.
Answer me that, my friend.
I'm glad you asked. Because if you actually look at the literature, I have a pinned post on my Instagram because so many people ask me this freaking question. And I'm like, just go look at my post. Because there's like 10 articles pinned there that show that actually, in the case of melanoma, low vitamin D is associated with melanoma incidence and severity.
Low vitamin D is associated with melanoma.
So vitamin D is primarily made in response to the sun in the skin.
Right.
UVB light interacts with 7-dehydrocholesterol in the skin, stimulates the production of pre-vitamin D3. That can go and be processed in the liver and the kidneys, ultimately to make the monohydroxy and the dihydroxy form. And that's associated. We can use that 25-hydroxy form, which is like the storage form of vitamin D. There, yes, that's it, exactly. So that's associated with your sun exposure habits. So the 25-hydroxy storage form in the bloodstream is a pretty good proxy for your sun exposure habits, and that's why you can use apps like D-Minder, which essentially allow you to start a timer. You put in your skin type and like how many clouds there are, and then it will tell you how much vitamin D you're making per unit time. And it's pretty close, like it's pretty good prediction. Now, in addition to that, we also see that people who work outdoor occupations have lower levels of melanoma than people who work indoor occupations. We also see that people who have chronic, regular, daily sun exposure have lower levels of melanoma incidence and severity than people who avoid the sun altogether. The problem, as emphasized in the literature, is really intermittent sun exposure, which is when you never go outside and then you go on vacation to the Bahamas, you blast yourself for 3 days, you get burned to a crisp. That's a problem. But when you're getting daily sun exposure and you're chronically building that solar callus, as Jack would say, you're not only giving yourself all these other benefits, you're also protecting yourself against melanoma. And not to mention that like there's no discussion of risk-benefit analysis in this sun, like let's say the mainstream propaganda around the sun.
Yeah.
Because if you were actually to look at that risk-benefit, you could say, okay, Maybe if you're, not going outside very much and you're going out in the sun intermittently, you could have a slightly increased chance of like basal cell or squamous cell carcinomas. I would say the data is still kind of out on the melanoma unless you're really frying yourself regularly. But also, if you're going out into the sun, you're protecting yourself against cardiovascular disease, other cancer types, breast, colon, prostate, blood cancers. You're protecting yourself against neurodegeneration, Parkinson's disease, like dementia in general. And so if we look at the whole picture, it becomes really clear, like, okay, our number one killer is essentially like cardiovascular disease and like neurodegeneration is not too far behind.
Right.
Those two diseases are literally like completely protected against in the context of chronic regular sun exposure. Like the rates are dramatically lower among people who engage in those practices.
Wow.
But nobody talks about that.
Wow. That's so crazy.
I know.
Okay. What you talked about something to do with sunglasses. Why are sunglasses bad for you to wear outside?
Yeah, so you can think about sunglasses as being the same as sunscreen except for your eyes and brain. So UVB light is required to stimulate POM-C in the skin, and that goes into the bloodstream as like the peptides we talked about. But also, in order to get the production of these peptides in the brain, we also need full spectrum sunlight coming in through the eyes. So if we're wearing sunglasses that are preferentially blocking UV light, that we're not getting that stimulus in the brain to produce POM-C. And it's actually really interesting, but if you look into POM-C biology, the only way to unlock all of the cleavage products is in response to UVB light on the skin and the eyes in combination. If you're only exposing one or the other, you're reducing essentially the total concentration of those peptides being produced because you're only getting production, let's say, either in the skin or in the brain. You're not getting them at the same time, and that means you're basically lowering your potential to raise the levels of these peptides because you're not engaging the whole system together. And so when it comes to like, you have a question?
I was going to say, is it true that you won't get a sunburn if you don't wear sunglasses?
Well, there's no centralized research on it. I hope to study that in my light lab.
Self-studies? Self-experimentation?
I've had dozens of people literally tell me that they stopped wearing sunglasses and going outside and they haven't burned.
Wow.
Even like light white people going to like, very southern latitudes, not burning, and they were shocked. So it makes perfect sense when you think about this story of POM-C being cleaved to alpha, beta, gamma, MSH. The melanocyte stimulating hormones are telling the melanocytes to make melanin in response to the sun. So why would you want to block your ability to make new melanin? Instead, if you're blocking that, you're going to burn because now you're not making the melanin synthetic response to help harness the photonic energy of the sun and protect your skin and also give you the benefits of the free energy production.
And also there's something that happens, I've experienced it, when like I'll be in the ocean for like 6 hours surfing and I'll get this what's called surfer's eye, where my eyes will get bloodshot. And some people even experience this thing where they get like these crazy, what's it called?
Pterygium, I think.
Yeah,
it's like a little skin flap that forms on the eye.
Yeah, it forms like right over like the iris. Yep. What is that all about? And how would you avoid? Is that just from overexposure, like you were saying earlier, not spending enough time in the sun and just going out and blasting yourself for 6 hours straight in the salt water in the sun? Yeah,
so I think what that primarily is, you're going to get that in conditions where there's a lot of glare. Same with like cataracts. If you're in conditions where there's a ton of glare, like on snow or on water, you're not only getting the direct rays from the sun, you're also getting like a double dose essentially because it's reflecting off the water as well.
Right.
I would actually argue that it's more the blue light than anything because water, like if you look at the ocean, it looks kind of blue, right? That's because actually seawater and water in general reflects blue light. It doesn't like to absorb blue light. It doesn't like blue. And that's why it looks blue, because it's reflecting blue.
Oh, wow.
So that means you're actually getting more blue light because you're getting the 25% from midday sun, and then it's also reflecting off the water. So you're getting like a double hit essentially of the blue. And blue is also a short wavelength light. It's known to be associated with cataracts, with some other conditions as well. Obviously, UV light is very short wavelength, so I'm guessing it would probably be a combination of those. So if you're not somebody who goes out regularly and your eyes necessarily aren't used to that much light, and then you're going out and surfing for hours or whatever, like I would predict, my hypothesis would be that you would be more susceptible to issues like that than somebody who's out daily getting the regular natural light in their eyes. Then it's not that much of a leap But if you're going from like indoor to surfing for multiple hours, then it makes sense that you get more bloodshot and maybe get the pterygium and other things like that.
And what about people who like go fishing for like a whole day, for days on end, where they're like, not only are you surrounded by the ocean, but you're also on this white reflective boat.
Yeah. So, I mean, these would be the very specific use cases for sun protection, like eye protection.
So sunglasses would make sense in that case.
Like, either sunglasses or even blue blockers could work in that case, because you're going to be blocking UV light, and also because the lens is going to block at least most UVB, probably most of UVA. It's going to block blue, obviously, because they're engineered to do that. So that could be a good use case, even for blue blockers, which obviously have a use in other
Is there any
areas, too.
downside or benefit to polarized sunglasses versus regular sunglasses, or are you aware of any of that?
No, I don't know. I'm not sure. I haven't looked into them because I'm like, no, sunglasses. Most people don't need them. But obviously, if you're surfing, snowboarding, or other very specific use cases, you may want to invest in some eye protection and also just build up your tolerance over time.
Right. Have you heard of, I talked to Jack about this guy, Dom D'Agostino.
Yeah. I had a call with him last year.
He lives right down the. We talked about him on the phone. He has this idea. I think he was mentioning he was going to talk to Jack about, where he has, I guess, it's a hypothesis about exploding cancer tumors using red light and hyperbaric oxygen. What do you think about that?
So we already know that certain tumors are pretty responsive to hyperbaric oxygen because, again, their mitochondria aren't working very well. And so they actually can't handle a ton of oxygen because it basically can create a more reactive environment. Red light is also very stimulating to the mitochondria. So if the mitochondria are like broken and you really like blast them with oxygen and with red light, then it makes sense that could create, basically maybe push them over the edge, versus the other cells can tolerate it because they're functioning well. And so that's kind of a leverage point for a lot of cancer therapeutics, whether it's also ketones, for example, used in like glioblastomas, along with hyperbaric oxygen. And you can essentially leverage the fact that other cells' mitochondria can use these substrates effectively, but the mitochondria in the tumor are going to be less effective at doing so, and then they're going to be essentially preferentially starved out, especially in the context of like ketogenic diet or fasting, where they really want more glucose to run at a basic level. And that's what the Warburg effect is. Basically, it was discovered by Otto Warburg back in I don't even know when it was. Maybe
Warburg?
Yeah, maybe early 1900s. That tumors really love to just take up glucose and spit out lactate. They're running glycolysis like crazy. And that's also likely related to something called the pentose phosphate pathway, which is an offshoot of glycolysis that is required to make nucleotides that are required for like DNA synthesis, for example, and is also required to make NADPH, which is a reducing agent that is helpful for reducing the inflammatory reactive burden of cells. And so basically cancer cells can run glycolysis like crazy using glucose. They can also run some PPP, the pentose phosphate pathway, and they can make energy really quick, but it's not really sustainable. More recent research, so in my lab at Princeton, the Rabinowitz lab, which is like a top metabolic research lab in the world, we showed that actually tumor cells can burn ketones, but it was like pretty cool. So we had like pancreatic tumors. This was in like rodents. And we basically mapped which cells were using ketones and which weren't. And it was like the ones that were close to the blood circulation, close to the feeding artery, were able to burn the ketones. They had more oxygen available. The mitochondria were probably functioning a bit better versus like the core of the tumor wasn't burning ketones at all. It was like really burning a lot of glucose. And so there's, of course, some relationship to like hypoxia there. And when you have a tumor, it can begin to starve the tissue of oxygen, creating a more hypoxic, acidic environment that then can also drive the tumor progression and like things like hypoxia-inducible factor 1, HIF1, and other technical things that you may not care about. But anyways, they're like tumors have specific phenotypes and features that kind of make them able to be exploited. And then you can use that as like a therapeutic approach because other cells will be able to tolerate the stimulus, such as hyperbaric oxygen or ketones or like ketogenic diet, things like that. But again, it's still not dealing with the issue at hand. We really want to be focusing on bolstering like the whole body's metabolic function. And if we're not doing that with light, at least as a part of the solution, then we're really missing the point, in my opinion.
The ketosis stuff's super interesting because it's obvious that there is like documented, like proven evidence that ketosis can cure all kinds of things like Epilepsy is one of them.
Yeah.
I think Dom figured it out for
That was
like
one of the
people who
use
are getting
cases.
for people that like oxygen rebreather, toxicity seizures, like that kind of stuff. People that want to lose a lot of weight.
Yeah. So you actually reminded me that I never fully answered your question about like melanin in the eyes, because
Yeah.
if you live near the equator, you have good sun all year round, essentially. You also have access to carbohydrate-rich foods all year round because they're able to grow because there's good sun and not cold temperatures.
Right.
So in nature, that's yoked to more deuterium essentially in the diet, because carb-rich foods, roots and fruits essentially, are high in deuterium relative to animal foods, animal fats, and proteins, which are very low in deuterium. However, when you are getting good quality sun, your body's actually able to deplete deuterium more through sweating and some other mechanisms. For example, when you are exposed to UV light and it's interacting with melanin in the skin, I said it can split water. It can also reform water and specifically deplete deuterium while it's doing that, because this is also research that hasn't been done yet that I want to do, but Gerald Pollack's work on the fourth phase of water and like this exclusion zone water, if you've heard of that. So, you know, like solid, liquid, gas are forms of water, but there's this fourth phase that was discovered in like 2011 maybe by Gerald Pollack called like the fourth phase of water, or gel state water.
The days may be getting shorter this fall, but the action on DraftKings Casino is here to stay. Play hundreds of games with endless excitement like me. I don't get bored because I'm hammering bets all day long. I'm constantly rolling a play while the guests are talking. They don't even notice. Try your hand at classic table games or set the slots on fire with the fan favorites like Cash Eruption. It's great because I don't have to get off the couch and drive to the casino or get pestered by scanty cocktail waitresses all night long. And Steve doesn't even know it, but I'm also winning on his account as well. New players can play just $5 and get 50 instantly in casino credits. Download the DraftKings Casino app and sign up with code DannyJonesPod. Then press play on your favorite games to join the fun. The crown is yours. Gambling problem? Call 1-800-GAMBLER. Or in West Virginia, visit www.1800gambler.net. In Connecticut, help is available for problem gambling. Call 888-789-7777 or visit ccpg.org. Physically present in Connecticut, Michigan, New Jersey, Pennsylvania, West Virginia only. Void in Ontario. Eligibility and other restrictions apply. One offer per new casino customer. Casino credits are non-withdrawable and expire within 168 hours. Terms at casino.draftkings.com/get50. Ends November 24th, 2024. Again, go to the App Store and download DraftKings Casino app and sign up using my code DannyJonesPod, DannyJonespod.
And this is like a jelly-like form of water that actually facilitates metabolism. It literally is a battery. It separates positive from negative charge in a similar way that mitochondria do, except this is actually in the water within cells. So cells can only really access this exclusion zone water if it's deuterium depleted, because the deuterium depleted water is much more effective, this is the hypothesis, at being structured into this state. And the things that stimulate fourth phase water production are primarily far infrared light, 3100 nanometers, you get that from the sun, but also UV light as well. And so this water actually facilitates metabolism. So in biochemistry, and I remember being deeply unsatisfied by the answers to this question that I asked when I was in undergrad, that like, how is ATP providing free energy? What does free energy even mean? Because we think about ATP as a cellular energy currency, and it's just like providing this nebulous concept of free energy, and it's able to support metabolism. But what actually is happening, I've come to learn over the past almost 2 years now, is that ATP can basically phosphorylate proteins, enzymes, and metabolism, let's say. When it donates that phosphate group, the enzyme is able to change shape. The structured water is then able to go inside, and that's what actually powers the metabolism to occur. So it's the ATP is facilitating the process, but it's not actually providing the energy. The water, the structured water, is actually what's providing that energy in the form of this like charge-separated exclusion zone water. And so if the mitochondria aren't functioning well, now deuterium starts accumulating in the cells. That can also occur if you're eating a ton of carbohydrate-rich foods in the winter, because you're not getting access to that sunlight that you need to actually deplete the deuterium from your body. And that's also just makes perfect sense if you think about a more ancestral diet. If you live somewhere where the ground freezes, you're going to be eating more animal foods in the winter.
Right.
That's what you're going to have access to. Maybe some ferments, maybe some berries, but it's like pretty minimal.
Right.
Compared to like the spring through fall, you're going to have access to more plant foods, but you also have access to better quality sun that's going to allow you to handle the deuterium that's coming in through the diet in a productive, non-harmful way. So all of the processed foods as well, like the hyperpalatable foods, are all deuterium bombs. All the seed oils, super deuterium bombs,
Right.
all of the carbs and the grains, like they're so bad. Combine that with, not moving your body, never sweating, not getting out into the sun. Now your body is literally accumulating this burden, and the mitochondria, like I mentioned earlier, they can't deal well with deuterium because that rotor that spins only can take protium. So now if you're accumulating this deuterium, it can start to break the engines. It can start to break the mitochondrial engines, and now you're dealing with some issues because now you can't make the energy and water that you need to actually support your tissues function. But anyway, this ties back to the melanin story because if you live somewhere near the equator, you want the dark skin and the dark eyes to help handle the intense light that's coming onto your surfaces. Right. Versus in the more northern regions where light is scarce for a decent portion of the year, the very, very light blue eyes and pale skin allows you to scavenge more light from your environment because that melanin's not there to soak it up and sequester it.
So you're basically a light vulture if you're living up there. You're just doing anything you can to get every last drop of UV light from the sun.
Exactly. And it's actually pretty interesting because if you look at like the latitudes, so where I'm at in New Jersey, it's like 40th north latitude. Down here, I think we're around like 28.
Yeah, we're pretty close to El Salvador down here.
Yeah, so El Salvador is like 13. So, I mean, it's like 10 degrees difference. But
it's like an hour flight.
Yeah, it's not too bad at all. I'm excited to go visit next month. But the latitudes that cultivated the very light eyes and light hair and light skin, they're like super north. That's like Scandinavia status.
Right.
So it's actually pretty interesting, and this also ties into like the lability, like let's say lability or like the flexibility of life, because if you have a very what's called uncoupled mitochondrial haplotype, what that means is that your mitochondria have uncoupled the flow of electrons from energy production in order to make heat. Mm-hmm. So uncoupled mitochondria come from more northern regions. Coupled mitochondria come from equatorial regions. The coupled mitochondria are really efficient at making energy. They have very tightly coupled the flow of electrons to the production of energy and metabolic water. And that's why you see the top marathon runners in the world coming from like Kenya at like high altitude equatorial environments. Their skin is like purple. It's like so dark. They have so much melanin. That's super coupled mitochondria, super efficient. That's why, again, they can run 23 miles and kick everybody else's butt because their mitochondria are so efficient. Compare that to the uncoupled mitochondria that come from more northern regions. Those mitochondria have a flexibility to deal with the environment. So they can make heat in response to cold. But as Jack talks about, if you put that person from Sweden and you put them in Miami, Florida for, 10 years, and you look at their mitochondria, they can actually become more coupled. So they can kind of shapeshift.
Really?
And that's why...
So their eyes will get darker?
Their eyes won't get darker.
Oh.
Their mitochondria become better at harnessing solar photonic energy.
But if they have that light skin and those light eyes, then wouldn't they just be like soaking up way too much sunlight, and wouldn't it like override their system?
So the eyes... they can't really change, but obviously their skin. If you look at Jack, he's a Fitzpatrick 1, but he's tan as hell.
He's a what?
So there's different skin types. Fitzpatrick 1 is the most pale, like Irish and Scandinavian.
Oh, okay, yeah.
Fitzpatrick 5 is like dark purple skin, essentially.
Oh, okay.
It's a range.
Right.
So Fitzpatrick 1, like if you have really pale skin, you have an incredible potential to still develop melanin. It just requires the stimulus. But the person with the really dark skin, they can't deplete their melanin to make it paler. So that's why you also see amazing, like very vast health disparities in, let's say, Black populations in America, because their skin and their biology has not evolved to be here. And we see, like, obviously there's socioeconomic aspects to that as well.
Or inside all the time.
But they're inside, and they're also not receiving the intense sunlight their bodies were designed or evolved to receive.
Right.
And so that has major implications for, like, cardiovascular disease, diabetes, and we see these diseases in particular immensely affecting Black and brown populations in the U.S. And it's literally a biological mismatch versus the people who have very pale skin and light eyes, let's say. They have some flexibility to adapt to their environment, which should make sense because we came out of like the breadbasket of humanities, like in Africa, migrated out slowly over time, skin got lighter, eyes got lighter.
Right.
But the people who now have those lighter features can still have the plasticity to go back, not fully, but they can develop melanin in their skin. They can harness more of the photonic energy by getting a tan. But the people who already are more ancestrally, look more ancestral, they don't have as much flexibility, so they need to get more UV light and more natural light and more time outside than people who have lighter skin, just because their melanin really is desiring that to allow them to power their bodies effectively, essentially. And so obviously there's implications there, but I also think we can develop healthy tech to help people like that. Like, let's say you can't afford to move, but maybe you can invest in some UV light panels for your house and use them outside or with a red light panel and help to give you some of that photonic energy your body's looking for.
First of all, are you drinking that deuterium depleted water right now?
No, actually. So I couldn't bring it on the plane, but I pregame with deuterium depleted water.
Why can't you bring it on the plane?
Because they won't let me have like beverages. Like I can't buy it at the airport and then like, yeah, because it's pretty uncommon. It's pretty expensive.
Do you drink it every day, or is that like a normal thing for you or no?
So I use it specifically for certain contexts, like for pre-gaming for a flight. Like I don't like flying. Usually my body doesn't respond that well to it. Like I said, I had a lot of health issues as a kid.
A lot of radiation on the airplane.
Ton of radiation, plus the Wi-Fi. It's literally like a microwave.
Yeah.
And so I pregame for like a week before the flight. I'll do deuterium depleted water, about 105 parts per million. I'll dilute it. I buy like the Cularivia, I think it's called. There's a couple different brands, like light water as well. I'll dilute it to about 105 parts per million with my normal drinking water. And then I'll drink that every day leading up to the flight. I'll also chug a few ounces of the straight, like 25 ppm deuterium depleted water before the flight. I also took some ketones. I also fasted that morning, and then I just ate like meats and fats that day. So in a way that like could prepare my body to deal with that stress, because it's basically supercharging the mitochondria to get the deuterium depleted water, the ketones. The ketones are the most efficient fuel source for mitochondria. They make more energy on a per carbon basis than any other substrate like glucose, even compared to fat, amino acids.
I've told this story a couple times on this podcast, but I've done probably 2 or 3 times in my life where I've done a 7-day fast with no food. And every time I do it, it's like I'm fucking dying and being born again. It is like the craziest thing. The energy that I have on day 5 is ungodly. I remember the first time I did it on day 5 of no food, and I drank I got it from some website. I forgot. I think I learned it from Kelly Slater was talking about it on a podcast with Joe Rogan, where he drank, that's where I got the recipe for it, which is just, it's water, tons of lemon juice, and maple syrup, where I would just drink that. And and cayenne pepper. And I guess Beyonce has the same. There's like a Beyonce
I had that when I was like
thing.
15.
Yeah.
I would do that cleanse.
Yeah. So I did that basically for 7 days. And on day 5, I was like, I wasn't even thinking about food anymore. And I remember I went to the gym and I can typically do like to failure, maybe like 15 or 20 pull-ups. I was able to do like 50 pull-ups, like easily.
Whoa.
It was insane the amount. And also I played basketball, full court basketball. Typically like after 15, 20, 30 minutes of playing full court basketball, I'm starting to feel fatigued. I'll get like the cramping in my ribs or whatever, and I'll like have to take a lot of breaks, right? And chug a lot of water. I was able to play full court basketball for an hour with no breaks, like without any of that stuff. Like it was like my body, I felt superhuman.
Did you check your ketones during that time?
I didn't. That was before I had any of that stuff. That
okay.
was like,
I'm just curious because you were having maple syrup, so I wonder how much that would like suppress it. But
right.
How was your sleep?
For the first like 3 nights, it was pretty rough, but after that, it was great.
Okay. Because I know most people, if they're just doing a fast with just water and like not adding any sugar or ketones or anything, like typically you only sleep a few hours, like maybe 4 or 5 hours.
Oh, really?
Yeah, because the body's essentially like, you need to go hunt. You need to go find food. This is like survival mode.
Right.
So it's more sympathetically driving. That's also why you feel more energized on like a fasting or even a keto diet to a certain extent, because basically your body thinks it just needs to go forage or whatever or hunt. But I mean, I know my partner did like a 5-day fast recently, and like he was not sleeping and he was like super energetic, and it was like, wow. But usually people's lifting goes down, but maybe because of the maple syrup, you were able to maintain some of your glycogen.
Well, when I did like workouts or whatever, I only did body weight stuff because I knew that I wouldn't be able to do like any kind of heavy stuff with no food or fuel.
Well, that was one thing I noticed.
I'm curious about the maple syrup though. I wonder what that would do. That's a good question.
Usually it would probably keep ketones a bit lower than you would have reached otherwise. Typically fasting, you can get to like 3 millimolar or maybe a little bit higher for your ketone levels at that length of time.
I have the thing now, the one that you blow into, and it tells you.
Yeah.
I forget the name of it. The thing was fucking expensive.
Yeah, that's like the acetone meter.
It's a ketone. It tells you your millimoles of your ketones or whatever. It has like a.
Yep.
I forget the name of it.
I know exactly what you're talking about. Yeah.
The reason I did that fast was I learned that there's like some sort of plaque, mucoid plaque that builds up inside your digestive system that like basically lines your colon and your intestines, and then it basically stops it stops nutrients from being absorbed into your body. And it's from like years and years of eating shit and not fasting. Are you familiar with this, or is this bullshit?
So, I mean, there's biofilm in your gut. It's not necessarily a bad thing. Actually, that mucus.
I thought it was called mucoid plaque or something, like a plaque that builds up inside on the walls of your intestines.
Possibly. I don't know in particular if that approach would be specific for that. I mean, what you're doing when you're fasting is you're also starving your microbiome. So it's like becoming way more depleted. It's pseudoscientific, son of a bitch. I'm dead.
A pseudoscientific term for a combination of mucus and food residue.
I'm so dead.
And some alternative medicine advocates claim coats the gastro. Son of a bitch.
Yeah. So okay, I feel very confirmed by my intuition around that. Then okay, yeah. So there is maybe something there. So like you have mucus throughout your gut. It's actually really important. There's a group of bacteria that live in the mucus called Akkermansia muciniphila. As the name implies, they love mucus. They actually eat the mucus, but when they eat it, they stimulate the production of more mucus. And that actually helps to maintain healthy gut permeability. So we know that basically depleting Akkermansia is associated with obesity and metabolic syndrome, because essentially you're like absorbing more calories and nutrients from food, and you're also absorbing other stuff too, like endotoxins from other bacteria and things like this. So the mucus is actually really important, but you could develop dysbiosis. Not going to say from like nicotine pouches or anything, but like we don't want to talk about that. But we
can talk about it. So what are you saying about nicotine pouches?
So whenever you have an inflammatory impetus to the gut, it changes where blood is flowing essentially. So the gut is supposed to be hypoxic and low oxygen. That's what allows the right bugs to grow there, in the colon in particular. But nicotine, it's not supposed to be consumed orally. So when you swallow it, it's very irritating to the mucosa. It can create gastritis. It can even lead to ulcers. It can lead to ulcerations in the mouth as well, but typically less so. But if you swallow it, it can create inflammatory conditions in the gut that can create dysbiosis, digestive issues, gas, bloating, things like this.
So do not, if you're using the nicotine pouches, kids.
Yeah, kids.
Don't swallow the damn spit. Spit it out. Or if you're doing any of the hardcore shit like the Skoal or Copenhagen or any of that.
I don't know what that is, but
that's like the actual tobacco that they shoved in their mouth. Yeah,
you got to be like the wrestlers in high school.
Tucker Carlson is the biggest advocate for Zins. He says that it improves his erection quality.
Well,
he says it's the best thing that God has ever invented. It's like God's hand massaging his brain. He's a smart guy when it comes to some things. I think he's a really intelligent human being, but I think he is very overzealous on the Zins.
Well,
I think he does like a can a day of Zins.
That's too much. I was using Zins for a very short period of time, and I literally got suicidally depressed.
Really?
It was so bad, and like I was able to like detach and be like, this is not me. Like I've just never taken this again. So that was me. But like I have issues. I think I always had like slight histamine issues, and post-COVID, I had COVID really bad in like 2022. And I had like issues with parasite infection after that and like histamine stuff. But the Zins, because they work on acetylcholine, cholinergics are also related to histamine. And so histamine does a whole bunch of stuff. But
let me tell you something real quick.
Yeah.
The first time I ever learned about these things, I had a guy from Andrew Gallimore. He is a neuroscientist based in Tokyo.
Okay.
He's basically, it's a neurobiologist.
All right.
And he said he had this little can of these nicotine pouches with this Japanese writing on it because he was in Tokyo. And I'm like, what is this? He's like, it's nicotine pouches. I'm like, what? He's like, yeah, he was from the UK, but he lived in Tokyo. And he was like, it's neuroprotective. It's good for your brain. I'm like, really?
Well, Jack would add a caveat and say you need to get UVA light with your nicotine in order for it to be beneficial, which is true. And actually, Jack makes a really good point on this, especially recently he's been talking about this, that nicotine and other, if you look at the structure of nicotine, it has like rings with like some double bonds. Whenever you see that, it's called like an aromatic ring. Whenever you see that in a structure, think UV light because that structure can absorb UV light like crazy. All of the aromatic amino acids, tyrosine, phenylalanine, tryptophan, they all absorb UV light. So Jack talks about how actually it makes complete sense. If you think about the type of people who gravitate towards these things, they tend to be UV light deficient.
Yeah.
Also dopamine
slaves.
Right, exactly. So that can actually serve as a delivery mechanism for UV light to get to your brain. But in order for that to happen, you actually have to be in UV light as well.
So if you're doing the nicotine, don't swallow it and make sure you're getting sunlight.
Exactly. Or cold, I guess, in the winter.
Yeah, I have so many friends who don't spend any time outside and they're just addicted to everything.
Exactly.
Video games, sports betting, nicotine.
Well, when you're not addicted to the sun like nature intended, you're going to be addicted to other things because you're going to need the hit somewhere.
Right.
But when you're getting it from the sun, it's like cruising like this. When you're getting it from other things, it's like this. It's like up and down and up and down. It's a roller coaster.
All right. We were on like a very, very solid path, scientific path that you were leading me down. And I think I lost track. What were we talking about? What were we talking about before we started talking about nicotine?
Well, we were talking about melanin. And, like,
you were saying nicotine is
latitudes.
bad for the gut. Like don't swallow it. If you want nicotine, smoke it or just don't spit it.
Yep. Smoke. And I mean, obviously smoking, limit that if you're going to do it too much. Like then I would probably use something absorbing and like Bucoli or whatever. Actually, like transcriptions, they're methylene blue and nicotine troches. They're great.
What is it? Methylene blue and nicotine what?
Troches. They're buccal. They're like these little.
What are they called?
Transcriptions.
Transcriptions.
Yeah, they're great. They also make just plain
I'm making
methylene
up a
blue
menu
ones.
right now.
I know,
for
right?
myself.
And you basically tuck it between your cheek and your gum line, and it absorbs there. It will stain your mouth blue. Just warning, because the methylene blue is like a dye. There you go.
Oh shit.
These are great, especially for long COVID, because both the nicotine, so nicotine works on the ACE2 receptors as well.
So what is the effect you get from this? You get any sort
So
of...
this is
can
like
I catch a buzz
euphoric.
from this?
Yes.
Really?
Yeah, this also has CBD in it. So you feel good. It's also good for you. I obviously wouldn't abuse it because methylene blue, Jack talks about it decently.
Yeah, he says he gives people
but,
IVs of methylene blue when he does brain surgery on them.
Right. So there's certain situations. If you have mitochondrial dysfunction, let's say from long COVID or the jabs, you may want to use something like nicotine with methylene blue.
Is this, you have to get a prescription for this?
No, you can buy it online. Wow. Yeah, it's great. Highly recommend. I love it. They have the Just Blue troches as well.
So this is potentially a good alternative. It's gum? Or you just like sit it between your...
You just sit it between your gum line and your cheek.
Okay.
Methylene blue is actually very closely related to hydroxychloroquine. So like they're...
Yeah, that's what Jack was saying.
Close. Yeah.
What is like a practical use of methylene blue?
So
for every day, not just for brain surgery.
Yeah, I mean he would defer because he doesn't like to get into trouble with this because it's kind of a gray area online with like censorship around methylene blue.
Is there censorship really? Well, it's fish tank cleaner too, right?
Yeah. Oh yeah, it's also used in like research. My friend at Princeton uses it in his like zebrafish research to like stain embryos or whatever. But essentially what it can do is it does quite a few things. Jack would say that it works at the quantum biological level to help facilitate the movement of electrons, like quantum tunneling essentially. But it can help to make the electron transport chain a bit more coupled. So it helps with energy and water production in the mitochondria. So if you're in a condition where your mitochondrial function isn't very good, and maybe, like I said, long COVID, post-jab, or other situations where maybe your mitochondrial function is hindered, like, I don't know, some chronic disease states, then you may benefit from using it. Obviously, it's not medical advice, but it's very low toxicity. Obviously, again, you wouldn't want to abuse it, though, because it can have some drawbacks. It also works as an SSRI and SNRI, so if you're on certain psychiatric drugs, you can't use it. Like, what are they called? Like
depression drugs, SSRIs?
Yeah. So it can really help.
Prozac, is that like one of them?
It's a boost. Yeah, Prozac. There's another group of MAO inhibitors. Those drugs, you can't combine those with methylene blue.
Oh.
They're contraindicated. But for people who aren't on those, they can use it for mental health and physical health as
How many of those transcriptions would be safe to use in one day?
So each little square, it breaks into 4 pieces.
Okay.
I would typically use like 1 or 2 little squares at a time, like daily, maybe 3 days a week or something like this. Every other day, something like that. Oh, okay. Or you could do 3 days on, 4 days off. I wouldn't use it every day, depending on what you've got going on. if it's just for like a boost.
I think Huberman said that one of the guys in his lab a couple years ago or whatever was constantly chewing nicotine gum, and he was one who like he won a Nobel Prize.
Yeah, in the short term, and maybe you'll have colon cancer in 20 years.
Right? Yeah. If you're swallowing it,
Yeah.
right?
Most people do. Most people don't know.
Right.
I know people who destroyed their gums with those pouches. Like they literally
With the pouches?
Yeah, with the Zyn pouches in particular. Like my one friend in particular literally has to get reconstructive gum surgery because she destroyed her gums.
Oh, it's a girl that's doing it. Not many chicks use Zyn pouches.
A lot of the high performing ones too.
They do, really?
Yeah.
Wow. That's nuts. So, but that you wouldn't be able to mitigate that by spitting though. It's just because it's sitting there. It's
Well, she was really crushing them.
Oh, she was crushing them.
She was crushing them.
How many?
Like all the time. There was always one in her mouth.
Always.
Yeah. So like you want to make sure you're rotating where you're putting it, and then not all day, because it is very irritating to the mucosal, which is also in the mouth.
Right.
So be wary. Also, especially because we're now seeing a really strong link between the oral microbiome and overall health. So like if you have leaky gums, like if your gum line is inflamed and you're getting this exchange with like the bacteria in your mouth and your bloodstream, if you have like bleeding gums, inflamed gums, like that's a sign that it's basically a risk factor for like cardiovascular disease and certain like cognitive decline as well. And they even literally found the oral microbiome in the plaques.
They found what in the plaques?
The oral microbiome, like those bacteria in the plaques within like the arteries. They're finding them there. So it's being somehow transmitted from the mouth into the bloodstream and then getting caught there, fomenting inflammation perhaps. So yeah, we want to take care of our mouths. It's important.
Yeah, my gums bleed when I brush my teeth.
Has that always happened?
As long as I can remember. Sometimes it's worse than others. Sometimes I don't notice it. But I've heard what you just said before, and I always get worried. I'm like, oh shit, am I gonna die?
I mean, we're all gonna die, but
I do everything I'm supposed to do.
what do you do?
I get the sunlight. I eat good.
Okay.
Eat a lot of olive oil. Eat a ton of fish.
Do you oil pull?
Love fish. Huh?
Do you do oil pulling?
What's that?
Like you can use coconut oil or another type of oil, and you can basically swish it, and it helps
in your mouth.
Yeah, it helps to break down the biofilms, like the hard plaque and the soft plaque that can form along the gum line.
Really?
Yeah, because
Can you do it with olive oil?
Yeah, you can do it with olive oil.
So just swish it around in your mouth.
Yeah, for like 5-10 minutes. You can do it in the morning while you're doing other stuff.
No way.
And then
I
you can
put
brush
olive oil
after.
on everything I eat.
It's great.
I drown everything in
What
olive oil.
kind of olive oil?
Extra virgin olive oil?
Like what brand?
I don't know. Some shit I get from Publix.
It's probably not real. It could be cut with seed oils.
Really?
They do that.
Fuck.
You need to make sure you're getting a good one. I like Costa Rica. You've seen it on Amazon or like Whole Foods, but
Can you pull this up, Steve? I need to get a visual.
Yeah. Greek olive oil in particular is known to be the highest phenolic, so it has the most antioxidant molecules. Greek. Yeah. Greek's where
The
it's
one
at.
I'm using, I think right now, it's like a squarish looking bottle with a green logo. I want to say it's like California something.
Is it a glass bottle?
Glass bottle.
Okay. Yeah, California's all right, but
It's one of the more expensive ones. I have to. Steve, what you find this thing?
it's called Costa Rica. It's with a K.
Costa Rica olive oil with a K. Oh, I think I know what you're talking about.
Yeah. That one's great. It's higher phenolic. There's also other like medicinal olive oils you can get online. They're like super high phenolic. Very anti-inflammatory, antioxidant. I get the white bottle.
Oh, I've had that one too. Oh, Costa Rica. I do have that. I do
great.
have that. Those
I
are
love that one.
expensive.
They're worth it, though.
I have the red pepper one, the spicy one.
Oh, I never had that.
They have all kinds of flavors.
Yeah, I just like the white one, the white bottle. It's really good. It's very peppery, and you can really, the color is beautiful as well.
Yeah.
Yep, the early harvest, so it's high phenolic, cold pressed Greek olives. It's great.
So
Very medicinal.
So olive oil might be laced with like other oils.
Yeah, and they could put dyes and stuff in it too to make it look like better than it is. It's crazy. And also, if it's in plastic, that's already a problem
Right.
because it can basically dissolve the petrochemicals. From
Yeah,
that.
I had what's her name? I had Dr. Shauna Swan
Yeah.
in here. You familiar with her? Mm-hmm. That podcast scared the living shit out of me, what she was saying about all the studies that they did with people like in the 50s compared to now, with like the sperm count going down and the testosterone levels going down. And
Well, that's
people that
majorly
were
controlled by
in-
light too.
people that were in rural areas they were worse off than people in like dense populated cities, which is crazy because of all the chemicals are spraying on like agriculture and stuff in those areas.
Yeah. I mean, we briefly touched on like melanin's properties as a detox system, let's say. It's really, really important from heavy metal perspective, but also a reactive oxygen species in general perspective. If you live in a very reactive environment, if you can have a tan, you can really help to mitigate some of those effects because that melanin can sequester some of those reactive species. Your body can also pull melanin from your skin inside. So we need way more research in this area, but we know that melanocytes are derived from the same origin as like the brain, neuroectoderm. And neuroectoderm tissues with that origin are able to maintain diapedesis or like movement in the body. So we consider movement in the body like maybe with immune cells, also like, of course, metastasis in cancer. We consider it a bad thing, but some cells are meant to move around. And so actually a lot of people have had many people in my DMs, and even Jack talked about this with Rick Rubin as well. Like they go on a long flight and they get off the plane and their tan is like much less. Well, essentially what the body can do is it can pull melanin from the outside inside to help quench the reactivity that's going on from being in such a toxic electromagnetic intense environment. Yeah,
that's fascinating how that happens.
Yeah. So melanin is crucial. There's so many different aspects of our body that use it, but from like a detoxifying perspective or like a protection against the environmental insults perspective, we really need to focus on like the basics first. And Jack will frequently say like redox before detox, because redox essentially describes the net negative charge of the body, describes how well your mitochondria are working. All of the detoxification mechanisms our bodies have rely on mitochondria. So if our mitochondria are dysfunctional and suboptimal because, let's say, our light environment and deuterium load and our magnetic environment, also the electromagnetic environment in general, is poor, then we can't even begin to detox because our redox is broken. We don't even have the tools, the raw materials to do it. So we need to focus on the redox status first. And then if you want to support your detox pathways and this and that, you can do that. But we're playing a losing game if we're starting with detox and we're not paying attention to the mitochondria.
How much of this EMF, 5G, Wi-Fi stuff is real? Like RFK talks about it like penetrating the blood-brain barrier and all this stuff. Is that seriously? Is that real?
So, first of all, there's not been very good quality research on this.
Okay.
Primarily because Robert O. Becker got canceled back in the late 60s. He was the foremost researcher in this space. He showed that like just radio frequencies back then, which like AM, FM, whatever, were causing tumors in rodents and all these other effects on cells. And they were doing a lot of studies in his lab on like limb regeneration and things like that using specific frequencies. And I know you talked about that with Jack. But that research basically got buried after he went on 60 Minutes and his whole entire career was ruined basically overnight.
There's a whole chapter about him in that book, The Pentagon's Brain.
Yeah. Well, for that reason, we don't actually have high fidelity research to point to, and it's conveniently because they can just say, there's no evidence that it's unsafe. Well, there's no evidence that it's safe. In fact, the evidence that is there would suggest that it's not safe. And then if you combine that with like the fact that, first of all of these 5G, 4G, Bluetooth, Wi-Fi, et cetera, they're all forms of light. They're all part of the electromagnetic spectrum.
Okay.
So like I mentioned earlier, our mitochondria are electromagnetic antennas. They're sensing the electromagnetic environment to try to understand what is going on in the environment. Is it winter? Is it summer? Like, what does it look like? How do I survive and thrive in this setting? Well, these frequencies were not present in our ancestral environment whatsoever.
Right.
Very small amounts of radio frequencies can get through the atmosphere, like very, very, very small. Compared to what we're experiencing today, like our bodies have no idea what this milieu is because it's completely foreign. And so you can, at the very least, think of it as these frequencies are interfering with our ability to create coherence and to sense the environment effectively. But at its worst, you could see it with directly interfering with mitochondrial function, for example, which I wouldn't be surprised by at all, because if we look at, blue light, toxic artificial blue light being like probably the most severe non-native EMF we're facing, and then all the rest of them that we use for our technology together at the same time as not moving our bodies, not getting sun, toxic food, toxic water, forever chemicals, all at the same time, all the vaccine schedule, everything like that. So it's like, it's really hard to disentangle because it's multifactorial, the problems that we're facing. And it's not like if we just fix one thing, everything else is fine.
Right.
We really have to consider the synergistic, like the negative synergy between these inputs. And nobody's doing that research because it's not reductionist. It doesn't fit within the model.
So there hasn't been any real research since Becker.
No. There's been some sponsored by the FCC, but even in their research, they showed that there are potential harms here.
Do you think it's reasonable thing to say that these 5G breaks the blood-brain barrier?
Breaks it? I don't know about
or penetrates it. I don't know. What did RFK say?
I don't remember what he said. I don't know if I heard that, but
it was on the Joe Rogan. He started saying it towards the end.
Yeah, I don't remember exactly what he said.
Can you find it, Steve? Find a quote RFK talking about 5G and the blood-brain barrier. We can actually figure out exactly what he said.
But what I can say is when leaky gut and leaky brain are very closely linked because the cells that comprise the blood-brain barrier are very, very similar to the cells that comprise the tight junctions of the gut. And so whenever we have insults to the body that are affecting the gut, that also has an effect on the brain and like the permeability of that. So if you increase gut permeability too much, you start to get, lipotoxins and things like this coming from the microbiome and other things coming from the diet, heavy metals, et cetera, that should have gone out with the stool, but now they're kind of coming into the bloodstream because of the hyperpermeability. That's also directly affecting permeability in the brain. That can create issues with neuroinflammation. When the blood-brain barrier is inflamed, that can deplete the ability of the brain to take up glucose from the circulation, which essentially starves the brain in the absence of ketones. That's why ketones are so powerful in neuroinflammation and neurodegeneration, post-TBI, et cetera, because in those settings, the brain is inflamed, so it can't take up the glucose that it needs to survive, and so it will either wither or it can compensate by using ketones if they're available, but most people don't get into ketosis, they don't fast enough, they eat too many carbs, or they just don't know this, so they don't know to leverage like exogenous ketones, for example, or something like this to help mitigate the effects of head injuries, whiplash injuries, or even things like Alzheimer's disease and dementia and things like this that cause issues with that blood-brain barrier.
Yeah.
I had it.
There is whatever you said about like what you were talking. Okay, let's listen. Let's listen to what he says.
Okay.
Does all kinds of bad things, including causing cancer.
Wi-Fi radiation causes cancer.
From your cell phone. I mean, there's cell phone tumors. I'm representing hundreds of people who have cell phone tumors behind the ear. It's always on the ear that you favor with your cell phone.
That's true.
And we have the science. So if anybody lets us in front of a jury, it will be over.
So what is the number? Because a lot of people
There's a lot of people with it. They're glioblastomas. That's the kind of cancers that they get. But cancer's not the worst thing. They also, it opens up. Wi-Fi radiation opens up your blood-brain barrier. And so all these toxins that are in your body can now go into your brain.
How does Wi-Fi radiation open up your blood-brain barrier?
Yeah, now you're going beyond my expertise.
Okay.
Now we're in your field.
There are I'm going to use a number here, and you're going to think it's hyperbole, but it's not. There are tens of thousands of studies that show the horrendous danger of Wi-Fi radiation.
So it breaks the blood-brain barrier.
Yeah, so he said it opens it up.
Opens up the blood-brain barrier.
So that kind of makes sense to me because the cells that are controlling those tight junctions that protect against permeability, they require mitochondrial function to maintain their energy levels and bioenergetics to actually allow those junctions to be maintained. So if we're disrupting the mitochondria in general, it would make sense that you could begin to break down those barriers and increase permeability in both the gut and the brain. I don't know if there's any specific studies looking at that in humans. There's probably not. What he did say, though, about the cell phones and the brain tumors, I can actually personally attest to this. I had a client who was a model in like the early 2000s, and she was on her phone for like hours a day for different gigs or whatever. And she developed a tumor right behind her right ear where she always had the phone. And back then, the phones were even worse radiation-wise because they just weren't regulated as much, I guess. And
what year was that?
It's like 2001.
Oh, shit.
Yeah.
So it was like Nokia brick phones.
Yeah, exactly. There have been some steps in the right direction as far as I am aware from a radiation perspective. But she got this tumor in her brain behind her ear, got it removed. Her personality changed after that, irrevocably. And she had suicidal depression for years. And when
After it was removed?
After it was removed, yeah. And when she and her husband came to me for help, it was kind of like the 12th hour. And so I did what I can to help support her light environment and get her outside more. But it was like she literally killed herself while she was working with me. God. Yeah. But I even told them, I was like, this is really serious. I can only do so much at this point. So
she was just super depressed after?
Yeah. Super depressed. She was just no zest for life ever since getting that tumor removed.
Oh my God.
So it's fucking insane. People's lives can be ruined, and they'll get gaslight by the doctors. Her doctor even said, "Oh, it's probably not caused by that."
What do you know about childhood leukemia or like like really young babies that get like T-cell leukemia, and is there any, like, what is the consensus on like treatment for that? And is there any sort of like unconventional things like what we're talking about today that you believe can be beneficial to fixing that? That's something I really don't know much about, but I have a friend who has a kid that just got T-cell leukemia, and they have to like do a bone marrow transplant with the kid soon, and they've been through tons of radiation.
Yeah, I mean, like I mentioned earlier, chronic regular sun exposure is associated with lower levels of blood cancers and immune cancers. So that would be something like a non-negotiable. You just gotta, I mean, kids need to be outside playing barefoot anyways. We didn't talk about grounding, but when your bare feet are in contact with the earth and your palms, you get free electrons from the earth. Negative charge. Negative charge is what powers your mitochondria to make energy. So
when your body is touching the earth,
specifically your hands and your feet.
When your hands and your feet are touching the earth, it's going to give your mitochondria more energy.
Literally, it's free electrons from the earth. And
Electrons.
Yep. And you can look at the studies, and we talked about electrons earlier. That's what powers energy production in the mitochondria. But if you look at the studies on grounding, you can see even 20 minutes of grounding, they do thermographs, so they can show basically if there's inflammation in an area, they'll do like full body. So they'll show like there was inflammation in their face. And actually, fun fact, after a cell phone for like a few minutes, you can see the thermograph showing this inflammatory impetus within the face. The tissues of the face are hot. Ground for 20 minutes, everything cools down. So it allows you to maintain healthy redox status, redox being that net negative charge. So if you think about our ancestors, we were always grounded because any material that is natural will facilitate that flow of electrons. So if you're wearing leather on your feet, for example, or hides or whatever, cotton even, that all allows that electron to flow. But now with all of our rubber-soled shoes, our synthetic fabrics and everything like that, we're blocking that electrical connection to the earth. And we're cutting off basically 1/3 of the electron supply we're supposed to get. When I think about bioenergetics, most people think about food. Food is only 1/3 of the story. We also have direct exposure and stimulation of melanin in the skin by the sun. Like I said earlier, that makes free electrons and free energy. And we also have the third pillar being grounding and direct electron exchange from the earth. We're really only getting one of the three pillars in the modern day from the food, and most of the food is BS anyways. So our bodies are starving to death. And that's actually how I see diabetes. I'm going to go back to your leukemia story in a second, but diabetes I really see as like the body is starving because the tissues, the muscle in general, the tissues can't take up glucose very well because insulin resistant. They also can't burn fat or ketones really well either because the mitochondria are dysfunctional. That's like the root of the issue in insulin resistance and in diabetes. And so if your tissues can't burn anything, they're literally just shrinking away. And that's why we see sarcopenia and like muscle loss and frailty being associated with metabolic dysfunction and insulin resistance. And the tissues just need food. They need support. But food doesn't have to be food that you eat. Food can also be sun on your skin and your bare feet on the earth. People don't realize that.
Right.
And that's also something I want to study in my light lab is that like nobody's looking at these kind of interventions, like just putting people outside in nature under natural light because it's not lucrative, I guess. It's literally free 99. You don't have to have anybody else's prescription to go do it either.
Yeah, it's interesting, that connection with the electrons and like the grounding and the food. Like, because food is just electrons essentially at the end of the day, right?
Yeah, when you're eating food, you're eating for protons and electrons.
Right.
Of course, you're also eating for micronutrients that help to facilitate certain parts of metabolism. For example, there's like a cofactor in the enzyme reaction that connects glycolysis to the mitochondria. It's called pyruvate dehydrogenase. There's an enzyme called TPP. It's like, I don't remember what it stands for. Anyways, that enzyme is part of like a micronutrient that you get from a diet. You know how you get your B vitamins and vitamin C, vitamin A, etc., E, whatever. Those vitamins also play roles in metabolism and stuff. So you are also eating for micronutrients, but first and foremost, you're eating for protons and electrons to power your mitochondria. And if we think about it in that way, then we can be like, okay, where else do we get electrons from? Well, we can get at these two other areas that nobody else is essentially thinking about or talking about. And then when you think about it in that way, it makes total sense why we're kind of experiencing this energetic crisis as modern humans. But going back to your friend's kid, so, you know, getting into the sun, at least the epidemiology would say that that's going to be supportive in that context. We also know that, of course, I kind of mentioned this earlier, where depending on the hand of mitochondria you're dealt from your mom, that has implications for childhood diseases. And that's kind of the rub too. Like, and this is also the rub of decentralized science in general. It's like you have to be willing to take responsibility for what you create, essentially. So if you want to live like an asshole and like, not take care of your body, that's totally fine as long as you have informed consent about it. It's all really about informed consent. Like, you have to know what you're doing to your system. So in the case of, like, let's say a woman who, I don't know, abused drugs and sat inside all day, alcohol or whatever, didn't move her body, and then she has a kid, those mitochondria that she's handing to the child may not be optimal. They may be damaged. Some of them may not be very good at all. They could have a heteroplasmy, like that mutation burden we talked about earlier. They could have a mutation burden, let's say, in the mitochondria that form their liver that could look like a 50-year-old's liver when they're born. So it really just depends, like, how they get partitioned when those are happening. But we also need to talk about...
And those mitochondria are fucked for life.
No, so that's what I was just going to bring up.
Okay.
That's the beauty of mitochondrial medicine, is it's very actionable, and you can completely turn the ship around to a certain extent depending on when you start the interventions. So there are two processes we need to outline. We have mitochondrial biogenesis and we have mitophagy. So mitophagy is similar to autophagy, which you may have heard of, which is like when you fast, your body can break down.
Repair itself, cells repair. And
yes, it can break down. It's basically like the garbage men come out and they take all the trash, and then they can also repurpose the trash into do useful things with it. So mitophagy is similar in that in mitophagy, which is stimulated by red light and also like fasting as well, that you're essentially going to be tagging the mitochondria that are the most damaged to be broken down. So it's like the ones that have the most mutations, they can put up a little flag and be like, hey, you can take me out, not take out the good ones. They're self-sacrificing, essentially.
Yeah.
They can be broken down. Those raw materials can be reused. But in essence, what you're doing then is you're purifying the mitochondrial colony, because now you're selectively depleting the bad ones and you're keeping the good ones. Now, that's when the story of mitobiogenesis comes in, or mitochondrial biogenesis, which means that's the pathway that allows you to make new mitochondria from existing ones. So if you're optimizing mitophagy and depleting the bad ones, and you're also replicating the good ones, now, in effect, what you're doing is you're basically purifying and expanding those purified mitochondria. So now you're restoring health at the tissue level, and you're reducing heteroplasmy, you're reducing mutation burden.
Oh, wow.
Yeah. And so when it comes to mitophagy, this is why Jack always says, like, your smallest meal of the day should be dinner, so that when you're sleeping overnight, you're getting into a good fasted state.
Yeah.
And then when you wake up in the morning for sunrise, you're both fasted, in ketosis, and you're getting the red and infrared light from the sun. That's like supercharging mitophagy. That's really turning on that process.
Doesn't he also say that you should eat before the light kicks in or something like that?
You need to eat breakfast before UVA rise.
Why is this?
So we talked about this in episode 24 of my podcast, which basically was about the effect of UV light on mitochondria. So essentially, UVA light, when it interacts with mitochondria, it slows down mitochondrial electron transport. It slows down energy production.
What is the difference between UVA and UVB again?
UVA is slightly longer wavelength than UVB.
And that's in the morning, early.
Yes, so it's sunrise, and then depending on the time of year, let's say up north where I am in New Jersey, sunrise is like, I don't know, 7 o'clock. And then UVA rise is like maybe 8:15 right now.
Okay.
And then UVB rise maybe around 9, for example.
Okay.
It's not exact, but it's something like that. In the summer, you get a shorter window. And if you're near the equator, it's really short. Like UVA rise is like 15 minutes after sunrise.
Shit. Okay.
So during the summer, it's like you have shorter windows to play with. But essentially what's happening is your body is going to be really good at assimilating the nutrients and the electrons from food before that UVA rise, because the UVA is what's going to kind of put the brakes on mitochondrial metabolism, because it doesn't actually need that energy. Because if you're using UV light to power, let's say, energy production, you're powering the structuring of water as well, which facilitates metabolism. You don't need as much food. And this also directly relates to the alpha MSH story, because alpha MSH, like I said earlier, from UVB light, suppresses appetite. So your body's literally telling you when you're getting UV light, you don't need to eat, because you're not going to be hungry. You're just naturally not going to be hungry. If you're hungry, like, that could be a sign your light environment's off, or it could be that your body actually wants food. Maybe it's not getting enough energy from the sun or whatever. Maybe it's a cloudy day, or that's also why you need to eat more in the winter, because there's no UV light. You're going to be hungrier, and you also need to eat more fat and protein. You need the electrons. Yeah, you need the electrons, because there's less. You're not getting much from the sun.
Right.
And you're also needing more fat and protein from these animal foods to power heat production in the mitochondria. You need more mitochondrial function and activity, because it makes heat to help maintain your core body temperature. It also helps with the browning of fat. So brown fat in particular is very metabolically active. fat. Babies, like 35% of their fat is brown fat when they're born. That helps them to maintain their core temperature. Brown fat makes heat.
Okay.
The thing is, though, brown fat, you kind of use it or lose it. So a decent portion, I don't remember the exact amount, maybe like 20% of adults are walking around without any brown fat because they never get cold. So when you get cold, you can both preserve and amplify your current brown fat, and you can also cultivate something called beige fat, which is when your subcutaneous white fat starts to become more mitochondrially rich and cultivate more mitochondria. There's actually a paper out there that says like mitochondria give cells a tan, and it's because they literally look like brownish red. That's why brown fat, like when I used to dissect mice all the time, I cut them open, right on their back there's a butterfly shape of brown fat. It literally is brown. Because it's mitochondrially rich.
Even though they have all that hair on their back.
Well, you have to cut it open and then you like peel it open and under the skin.
Right, you would think so the hair still absorbs the light?
So the brown fat is to maintain their body temperature because small animals have a high surface area to volume ratio. They dissipate a lot of heat. Compared to us, our body size allows us to maintain a bit more of our heat, but for them, they are more active even at just like this room temperature is going to be a little cool for them, so they have more brown fat. So that brown fat is not only really good for maintaining heat, but it's also a major sink for glucose and fatty acids from the bloodstream. It's also a major endocrine organ. It's involved in the hormone system of the body. The brown fat. So the brown fat is in this axis with the thyroid, which allows it to take up T4, the inactive thyroid hormone, and spit out T3, the active thyroid hormone. So if you're cultivating your brown fat and you're getting cold regularly, you're doing cold plunges or whatever else, to maintain that brown fat, it's going to help to maintain healthy thyroid function. Combine that if you're like also getting sunlight while you're doing cold, for example. That sunlight, that far infrared light in the sun is helping to structure the water of the body, which is increasing that exclusion zone water, like I said before. That exclusion zone water is required for healthy thyroid hormone signaling. So people who are hypothyroid, for example, if they're just given a pill to like make up for that, we're not dealing with the issues at hand, which are likely low brown fat, because if they have low to no brown fat, they're not getting that proper conversion into T3, the active thyroid hormone. And at rest, they're like really cold averse. Like they want to bundle up all the time, and their doctor will tell them, oh, just stay warm, like stay bundled up or whatever, not realizing that's making the problem worse because now they're cold averse because they're not converting enough of that T3 to help support metabolism. Thyroid hormone is really important for stimulating metabolism at like a very fundamental level. But they're also, like also subverting the issue by, let's say, taking exogenous hormones. And in addition to that, if they're not getting enough sunlight, that far infrared light, they're also not structuring that water within their cells that facilitates thyroid hormone signaling. So cold and sun at the same time is like magic. So if you're in the ocean, even better, because the ocean is like supercharged grounding. You're getting the salt water that's very conductive. It's allowing more electrons into your system. Or if you're using something like a Morosco forage, which I have at home, which is like a cold plunge, it's fully grounded system in a metal tub. And I have like 10 pounds of Epsom salts in it. So when I get in there...
Epsom salts in it?
Yeah. Magnesium sulfate.
Really?
So when I get in there, it's like basically a mock ocean. Obviously, it's not as good as the real thing, but it's pretty dang close. And so it feels very grounding, relaxing, energizing. So you're getting all these benefits at once. And I put it in a spot where I get pretty good sun all day on it. So it's like, that's really, really good biohacking or bioharmonizing.
They're sending me one. I should have it in like 2 weeks.
That's so good. I'm so excited for you. I love my thing. I'm in there like every day.
Do they, what temperature do you have it at?
So Jack recommends between 50 and 55 degrees for the metabolic mitochondrial benefits.
Yeah.
I keep mine at 55 and I'll do like 1 40-minute session a week. And then I'll do like 2 or 3 between 10 and 30 minutes.
Okay. I have like a chest cooler at my house that I retrofitted into a cold plunge. I keep it at 40.
Okay. Yeah. How does that feel? How long do you stay in
there?
there?
It sucks. It's terrible. It's too cold.
Do you put salt in it?
I do it for like 4 minutes.
Okay.
No, there's no salt in it. I didn't know anything about the salt.
Oh, yeah.
hack.
So if you learn from Tom Seeger, he was the first guest on my podcast back in October, and he talked in the second part of our podcast about different salts you can add that can kind of like hack the system to make it even more beneficial. He'll do magnesium salts. He'll also do like copper salts and zinc salts. So it's like, depending on what you got going on, you can hack that a little bit. But the Epsom salts are like a really tried and true one that are just great for your muscles and magnesium status, relaxing, but also like kind of energizing at the same time.
Yeah, I've never felt the best I've probably ever felt in my life is like after surfing for an hour in 50-degree water and then like getting out of the water and it's still cold, especially in California.
Oh,
like you get out of the water, it's freezing. After getting out of the freezing cold water, it is probably like the most alive I've ever felt after doing something like that.
Yeah, I mean, it's no surprise. You're getting all these free electrons. You're getting the stimulation of the cold. You're getting the sun. It's like the perfect synergy to support your mitochondrial health. And we can sense that as like energy and vitality.
Right.
I think our brains are constantly surveilling our body's bioenergetic status, essentially. So when we feel low energy, it's literally like low energy availability. Like our mitochondria are not, like they're not working to the extent that we need them to be. So I think it's a really good readout. Like if people have brain fog or just like low energy, they're dragging their feet, they're sluggish, like that's a sign that we need to make some changes. Also, speaking of light, I want to make sure I mention this, is that there was a study earlier this year, I believe Glenn Jeffries published this, and it's about red light. And he showed that if you shine 670 nanometer deep red light on somebody's shoulder for 15 minutes, and then you give them an oral glucose tolerance test, which is basically a way to detect how well they clear blood sugar and their like insulin response. So it's like a standardized drink of glucose you essentially take, and then they look at how your blood sugar looks after you drink it. He showed that using that 15 minutes of deep red light on the shoulder and then doing the OGTT 40 minutes later reduced the blood sugar response by 30%. So now imagine taking your meals outside where you're not only getting 670 nanometer deep red light, you're getting all the light spectrum between 600 out through 3100 infrared light, like the infrared A light. While you're eating, now you're able to clear your, not only your glucose, but also other nutrients, your bloodstream as well. So it's just
shit.
Yeah. So if you, I already tested this myself, and I've met many clients that do that as well, wearing a CGM and then taking your meals outside, or wearing a CGM. Yeah, that's it.
Light stimulation of mitochondria reduces blood glucose levels. Wow.
Reduced by 27%.
That's wild.
And that was just from shining it on your upper back for 15 minutes. Now imagine like just sitting outside with your shirt off and like taking your meal out there. Like that makes a huge difference over time when you're looking at blood glucose dynamics, metabolic health. It's really just like a canary in the coal mine. It's a sign that like things are good. Like you're able to process those nutrients well.
Okay, now one more time, can you explain to me, like I'm a fifth grader, why eating breakfast before the UVB light kicks in is important?
Yeah, so it's actually UVA, but
UVA.
They're pretty close.
So basically like after 30 minutes of waking up, right?
Yeah.
Within 30 minutes.
So number one, you're most insulin sensitive first thing in the morning.
Okay.
So that means you can clear the nutrients more effectively that you're taking in.
Okay.
That's particularly true if you're eating in a circadian manner where your dinner's also pretty small, because what that means is then you're basically clearing, there's something called glycogen in the liver, stored glucose in the liver. You need to actually break that down before you get into ketosis.
Right.
Yes.
Yeah, Nick Norwood's explained this to me pretty well.
Exactly. So if you're eating a big, heavy carb loaded dinner meal, you're not going to get into ketosis during sleep. You're supposed to be getting into ketosis during REM sleep, the later sleep cycles. And then that really synergizes with the sunset or the sunrise rather in the morning to get mitophagy going. But if you're having that small, lower carb dinner meal, then when you're waking up, first of all, you should be hungry because if you had a small dinner, you're going to be hungry because that you're in ketosis as well.
Yeah.
And then you're eating in that first window, and then when UVA light comes into the picture, that starts to put the brakes on mitochondrial metabolism. So you're not, first of all, you're not going to want to eat as much because your appetite's going to be suppressed. So that should be a sign that things are working well. But just at like the physiologic or the cellular level, when the brakes are put on mitochondria, we don't need to make as much energy from the mitochondria. We're going to leverage other things like the water, for example, the exclusion zone water that is this battery that is directly essentially powering metabolism, independent of ATP. So it's more of like, I would say the details aren't as important. The main part of the story is that if you're eating in a more circadian fashion and you're in alignment with the sun, then your appetite should naturally mirror what's good for you.
Right. Yeah, that makes sense.
Yeah. And that means that when there's no UV light in the wintertime, you're going to be hungrier more. And you actually need that to help maintain your body temperature and your metabolism.
Oh, really?
Yep.
So even during the winter months when you are hungrier and you're not getting as much light, it's better to eat more often and more quantity?
Yep.
Wow.
Yep.
Fascinating.
You can just trust the signals your body's sending you, essentially,
Right.
if you're in this regulated state. If you're eating a lot of hyperpalatable foods and you're sitting inside all day getting your dopamine system hijacked, then you can't trust the signals your body's sending you because it's like telling you to eat crap and just keep
Yes.
sitting around.
Yes. The more I
Yeah.
sit around, the more I want to snack on shit all day.
Exactly.
How the way technology and the world seems to be evolving is essentially killing us. But we can't just be cave
No,
people
we don't have to.
our whole lives. Like it's like it's almost a way of looking at it is we exist to evolve technology. Like we literally exist to make better things. That literally drives our whole economy is innovating new shit, creating new shit, and consumerism, people wanting to buy that new shit.
Yeah, but I think we're innately curious creatures. I know Joe Rogan talks a lot about like us building or whatever the chrysalis that's going to become the butterfly.
Yeah, he
AI
calls
or
us the
whatever.
the sex organs of the machine world.
Yeah.
I think that was Marshall McLuhan who said that.
Okay.
But yeah, we're like creating we're like the electronic caterpillar or whatever.
Yeah. So I don't think that we have to go without tech, and I'm not advocating for that. But what I think that we need to do is be honest about the harms we're externalizing to ourselves so that we can make better tech. For example, Daylight Computer. They're making the world's first blue light free tablet. It's awesome. I have one at home.
Do you really?
Yeah. It's great.
Is it legit?
It's great. It functions
I got one of
just
those
like
on the way too.
awesome.
I'm
Yeah.
falling down the rabbit hole hard.
And they're going to make phones too in the future.
Really?
Yeah. And they're going to make other things too, like computer monitors and things like that. So if we just get really clear about what are the specific harms of what we're currently doing, and then we get creative, like we're great at innovating. Very good. So we can just figure out a different way to do it.
Yeah, I think that's really cool that there's people like the Daylight Computer and like these companies that make these red light panels, but there's not enough money in it. It's people. The world revolves around things that are cheap and efficient, and these things are not cheap or efficient.
Well, it could be cheap.
Like that's why Obama banned the full spectrum light bulbs,
Yeah.
incandescent
That's
bulbs.
not why he banned them. That was the cover for energy inefficiency. But like,
allegedly, right? I mean, did Obama really? Was he just really trying to make us all unhealthy?
I don't
and
think
fat?
he knew anything, but he probably has people in his ear just telling him what to do.
Right, to make
and
it
he's listening.
so the public reason for it was that they were inefficient and they were energy suckers, right? So we had to make these LED lights everywhere that didn't create heat and they were only blue light, which is essentially killing us. Then we have cell towers that are literally everywhere. There's telephone lines that go down every single street that get knocked out every time there's a goddamn hurricane, which is annoying for Florida. And all this stuff is essentially killing us. The environment that we've created is designed, not by design, but it is
Somewhat.
it's pretty much killing us.
Some of it's just out of ignorance, likely, and some of it is probably out of malice. I mean, when you learn about like the blue light technology and the mind control experiments, for example, like that's a pretty clear connection.
That's
You know
pretty
what they're
crazy
doing.
shit.
It is crazy shit. And it also makes sense just from like let's say a financial perspective, like you want people to be addicted to the thing you're selling. So like if you engineer it to make it in a way that like people want to use it more, then you want to do that because then you're going to get more money out of them. You're going to get more influence. So there's that. But I actually also talked about this with Jack a little bit, I think in our last podcast, where we're reflecting on like ancient Egypt and their likely use of crystals to harness photonic energy of the sun and convert it into other forms of energy. And so I think that's just as a kind of an example of we can get creative and figure out other ways to do the things we want to do. But first, we actually have to admit there's a problem. And that's what like nobody's talking about with the non-native EMFs and artificial blue light and things like this, where we haven't come to terms yet that it's a problem. So that's the first step. That's why getting that message out is important. So people can at least start thinking about it. People can build awareness. And people like Dr. Martin Moore-Eid, he was actually the guy who discovered, when he was a professor at Harvard, the suprachiasmatic nucleus in the brain of humans. That's that master clock. The master clock in the brain that tells all the other cells of the body what time of day it is.
Okay.
It's the circadian master clock.
Right.
So he discovered that, and he's been like really advocating and pushing for reduction of blue light and like healthy light in the indoor environments essentially ever since then. And it's just been like hitting a wall with the like lighting industry because they're basically just optimizing for energy efficiency and brightness. They're not understanding that light plays direct roles in regulating our biology.
And now it's a double whammy because everybody wants the Wi-Fi enabled light bulbs where you can change it from your phone.
Exactly. Exactly. Actually, on that note, there are light bulbs. The ones that I use at home have like a little remote control. They're infrared bulbs. So
yeah. Oh yeah. I need to add that to my menu. Tell me about that again.
Yeah. So they're really cheap. It's like $25 for 4 of them, and comes with a little remote, and you can turn it to like 20 different colors or like 10 different colors, something like that. And so during the nighttime, if you come to my whole house is red because I don't want to be blasting myself with bright light or blue light at night. So it's red. That also reduces light pollution. And then during the day, you can turn it on like a yellow color or like...
Do you have to manually do it or can you put it on like a timer?
There is a timer. I haven't actually figured out that function quite yet, but it's also really easy. It's literally just one remote can control all the bulbs. So you can carry it on you. You can keep them in different rooms. Super easy. But actually brings the point back to light pollution, which I wanted to make sure we talk about because... There's like really big implications to light pollution outside of our physiologic health and also like our psycho-spiritual health as well. So if you think about, let's say, late 1800s, there's barely a grid at that point. There's really no artificial lights at night. There's not these like cities that are just blasting light 24 hours a day. If you go outside most nights and you look up at the sky, you see like the vast cosmos every single night. And you just get this feeling of awe and wonder like at your both simultaneous smallness, but also your place in the universe.
2 nights ago, I was standing outside when we had no power, like on in our whole neighborhood. The whole half of Florida had no power, basically.
Yeah.
But my whole neighborhood was black, and I walked outside at like 9-10 p.m. and it was like almost like daylight. There was so much light in the sky; it was illuminating everything, and it was like looking at the world in a new way that I've never seen it like that. You rarely get to experience it.
Exactly.
It was fascinating. The moon was like super bright and it lit up everything. I could see everything.
Yeah, we're meant to like see the entire Milky Way galaxy essentially every single night. And when we're able to see that, it really puts things in perspective, I think, about what it means to be human and like what is life. And it brings up these like very like, I don't know, esoteric or like big questions. And I think it's really important for us as humans to have awe and like inspiration in life. But with light pollution, we're not only poisoning our biology and our circadian clocks and everything that has implications for, but we're also disconnected from like essentially the divine and the cosmos.
Yeah.
So when we're in that state, you know, that's kind of a fractal of all the other areas of our lifestyles where we see just like the soullessness of society, where it's like everything is just about materialism, like scientism is the new religion.
Yeah.
We've been like gradually moving away from like being religious, going to church and things like that. And we've been replacing it because I think as humans, we have circuits in our brain that are like meant to plug into that, to like some sort of a belief system around a higher order phenomenon. But if we don't have that, then we're going to basically use that circuit and put it on something else that it doesn't belong on, like government,
UFOs,
like UFOs, like science, like sports teams or whatever it is.
Yeah, I've always said that. If a UFO landed on the White House lawn and said, "We're here, this is where we're from, and we live with you guys, we've been here forever," all the people that are obsessed with UFOs and aliens would find something else to replace that, fill that gap with.
Exactly.
Something that's unexplainable that the human mind can't understand.
Exactly.
A God type thing.
Yeah, and I actually was just listening to a podcast that kind of ties back with the blue light story with on Aubrey Marcus's podcast. He had Dr. Robert Gilbert on, who's the founder of the Vesica Institute, and I'm actually taking a course with him on crystals right now. We'll talk about this crystal in a little bit. But he actually used to work in like the military industrial complex, and now he's very much
industrial military complex.
Yes, of course. And he's like now tapped in more into like the, I don't know, like sacred geometry and leveraging crystals and things like this. And we can talk more about that. But he was on Aubrey's podcast and they were talking about the purpose or the functions and the effects of different types of color and light. And he made a very interesting comment about blue light being used in esoteric practices to basically help to rigidify and make things be more stable. So like if you're trying to learn a new practice, for example, or like you're doing some sort of a meditation and you want to kind of keep that energy that you've cultivated present in your system, that you can use blue light to do that. And like I paused it at that point and I was like, that actually makes a ton of sense if you're thinking about like the way that we're inundated with blue light now. What if it's literally like keeping our spirits like rigidified. Like it's not able to move because we're literally constantly blasting ourselves with this like very, very dense blue light from all of our screens and our light bulbs, etc. Then it kind of actually makes sense that like we're no longer really spiritual beings. Like most people have no connection to any sort of higher order self or anything beyond the material self. And I don't think that's a mistake. And that's why this also comes back to the spiritual kind of war that's going on right now, where it's literally like a war over, like, I don't know exactly what it's over. It's clearly over control and power and money. But if it's, you know, other darker forces at play, I wouldn't also be surprised, because when you start learning about these other aspects to the light story and to the way our biology functions and how it's being hijacked, that it kind of comes to these conclusions that are pretty sinister, I would say.
So the blue light somehow, how are they using it in meditation?
So it's like it holds things in place. Holds
things
energy in place.
Oh, wow.
Yeah. So I was like, that's really interesting. I actually want to have my podcast and talk a little bit about that, because, I mean, the fact that we're just constantly bathed in this specific frequency of light is just completely abnormal. We already know that it's problematic from the dopamine perspective and the mitochondrial health perspective, but when we're talking about it at maybe like a more psychospiritual level, there seems to be something there as well.
Yeah, I just don't see any sort of way to turn this freighter that we're on, that humanity is on, or that our like society is on, to make it to where all of a sudden the biggest government and superpower in the world is gonna shift to technology that takes health as the first priority.
I mean, that's a really sad statement.
I don't see it.
But you know what could do it? A solar flare that takes out every grid all over the world, and suddenly overnight we have to start from scratch.
Yeah.
So it's like, it's a very fragile system actually when you look at it. There's a lot of givens that we're relying on that, you know, they may not actually be there the next day or the next week. You know, it's not really a given that we can wake up and have electricity and be able to go on our phones. Like, things can happen. Nature is pretty metal.
Yeah. I just got hit by 2 hurricanes in 2 weeks.
Exactly. Exactly. Yeah. So I don't know. I think we need to make considerations. And if we can do that in a way that is both supporting our desire to connect with other people and, you know, connect across the world, and also not harm ourselves, externalize this immense harm, then we should do it. And I really think it just starts with having conversations about, like, this is actually possible. And if we don't have the tech to do it now, that doesn't mean we can't have the tech to do it. And I am also very encouraged by the fact that, like, Bobby and Nicole and Tulsi linked up with Trump, and they're like literally on the precipice of getting in there. It looks like the poly market polls are like really strong at this point. I saw earlier today, like 20 points ahead or whatever. That if they get in there, like, Jack is directly in Bobby's ear, and I'm working directly with Nicole. So we can make some serious systemic change.
I like the optimism.
I mean, we have to at least try, right? I'm not going to give up.
You have to try. You can't give up. You know, it's the same thing when people say, you know, when people say, "Oh, you got to vote. You got to get out there and vote." And then, you know, the same people who think that it's important to vote, like let's say that you're, you know, a Trump supporter, and you want to say, you know, we got to get out, we got to go vote, we got to try to make a change, and we know it's corrupt, we know it's the elections get stolen and rigged. But the same people who think that it's important to vote, and that human beings, us, the citizens of the country, have the power to put the president in power. The same people think that the government is controlling the weather. So if the U.S. government is controlling the economy, the food we're allowed to eat, the drugs we're allowed to take, whether or not you can stay free from going to jail, depending on if you paid the exact dollar amount of taxes, and depending on how big your tinfoil hat is, if they control the weather, what makes you think they're going to let us decide who becomes the president?
Well, they are still working within the confines of the Constitution. They kind of have to, at least right now. I think that's why they're leveraging all these other points to try to control us, because they're, I think, ultimately scared that system's crumbling. And I do see that, like, the power structures are actually crumbling. We know too much.
Yeah.
Like, we're at a point in society where we're so connected, and the information age is really so here that, like, they can't hide anything anymore. They had an immense ability to control us in the past when they can control the exact narrative being pushed.
Yeah.
We're at a really different beginning of a different era right now. So I think things are going to be changing pretty rapidly.
Yeah, things are definitely, seems like it's heating up a lot right now.
Yeah.
And you're right, it is impossible to hide stuff. Like, you can't have like with the church commission hearings and everything that came out with like MK Ultra and all the stuff that was happening like during the Bay of Pigs and all like the Operation Northwood stuff, that some of the stuff Jack was elucidating to, like you can't hide that stuff there very much anymore. And there was just something that came out, I think it was last night I saw it. Steve, see if you can pull this up. It was I don't know how true it is, but if you Google the Defense Department codified a new some new right to deploy lethal force against citizens.
Yeah, I saw that as well. They said quietly.
Is this right here?
That's it. Yeah.
Boom.
It's not very quiet. It was all over social media last night.
Yeah, it's all over social media right now.
Yeah.
Oh, well, this is on a freaking. Oh, here we go. Okay, so it's on a forum, but this is the thing.
So yeah, this is exactly what I saw on Twitter. Can you punch in on it a little bit? It seems like nuts.
Let me. Oh, there we go.
Okay.
Here we go.
So it essentially like got rid of the law of using lethal force against citizens for whatever reason. But I guess this is like something that they would want to use like in the event of like a civil unrest or civil war, where the military would be able to take action against citizens. Pretty spooky stuff.
It's also pretty crazy to think that the military as a whole would be in lockstep with these initiatives. Because I mean, there's a lot of
Well, it's not the military. It's only the highest level of military, right? It's really like the generals or the people that are actually, you know, at the very, very top levels dealing with the like executive branch.
well, I guess if you're talking about like nuclear weapons or something like that, but for like foot soldiers, like
foot soldiers are different.
they're
right?
different.
Yeah, foot soldiers are different. Like there was I think there was like a poll or some sort of study I've heard of. I talked about with a few folks that I've had on the show, where they talk about like. I know, you know who it was? It was Rudyard. He was talking about how people in the military, like the low, like the foot soldiers, the people that are like in the Army and the Navy, they typically lean on like the political spectrum to more conservative.
Yeah.
But the generals, the people that are in command, the high level people that are dealing with like bureaucrats, politicians, and like vice presidents and presidents, they tend to be way more left.
Of course. Makes sense. Totally makes sense.
So, yeah, that's spooky.
It is. Yeah. I don't know. I think we're in for some really interesting times over the next few months, to say the least. But I'm really just focused on, I mean, a lot of people aren't even recognizing any of this as like reality, right? They're just really on the day-to-day. They're just looking down all the time.
Yeah, people don't have time. People don't have time to focus on this stuff. Like,
well, I think they have time, but they're misappropriating their time. And that's why I really, on my platform and, you know, everything that I stand for is really just trying to empower people to take back their health and their empowerment to do so in a variety of ways. And that actually allows you to see the reality that's right in front of your face. Otherwise, like, you can very easily just overlook very obvious things because you're just so, you know, wrapped up in whatever is going on your phone, on Netflix or whatever else.
Right.
So I think, you know, obviously that's a whole part of like the blue light agenda, really just getting you addicted to this tech, very hyper-focused on trivial things, essentially, while all of this like puppetry is going around in the background. And, you know, we essentially have the wool pulled over our eyes. But I think more and more people are waking up. And the more we can support our health at a very foundational level, the more we have fortitude to actually make big decisions and stand up for ourselves and our families.
Yeah. The sort of like the industry of medicine and like pediatrics is pretty crazy too. And like how the incentives work, especially like the vaccines.
Yes.
We, like with my kids, we decided not to give them like the full vaccine schedule with our pediatrician because they have like, you know, they're trying to push all these new vaccines on my kids and my toddlers and stuff like that. And we like last time I went in there, I'm like, no, I think we're going to skip that one. I don't think I want to do this with my kids anymore. And my kid's pediatrician had to kick us out.
I was going to say, did they dump you?
Yeah, they dumped us.
I've heard this so many times. It's sick. It's so sick.
I guess there's some sort of incentive. Like if they have a certain amount of their patients are they get vaccinated, they get some sort of like bonus or
The most of their money, I guess, comes from the vaccines.
The pharmaceutical companies, right?
Yeah.
They literally like are 90% of the funders for these places and these doctors.
Yeah. Obviously, incentives dictate outcomes, like Jack always says.
But it sucks because the lady, our pediatrician is great. She's like this super sweet lady. She like loves the kids, love her. She like actually like cares about them. And then we went to this other like holistic doctor. This dude was like 300 pounds overweight, and he was like, "Oh yeah, it looks good." Like didn't pay didn't pay close attention to them, to the kids, like wasn't able to answer any of our questions. So it's tough to find somebody who's good, who is not a part of the system.
So, I mean, are you looking for something just in case they end up needing it? Because, like, do the kids need a doctor?
No, but it's good to like take them in for checkups to make sure they're developing right, and
Yeah, I guess.
and make sure they're healthy, and
Yeah. I don't know. I mean, it's really important whoever you're interfacing with has your best interests in mind, because otherwise, I mean, you can't know everything.
Right.
You're just going to know whatever they say. Obviously, you're more inquisitive than most, but most people just trust their doctor that they're saying
Yes.
is like in their best interest, and then they
Right.
could end up being screwed over. I think that's the whole point in like decentralized medicine is like nature is your doctor. And anything, obviously there are certain conditions that need specific care. And if that's the case, then you can find somebody to take care of that. But by and large, we're taking the responsibility on ourselves to maintain and cultivate health and not outsourcing that to another individual that can't actually do the work for us anyway. It's a
Right.
ruse.
right.
Like being able to just drug whatever, that's a failing model. It's not actually addressing anything that's going on in your biology. It's really just, like we talked about earlier, numbing a symptom or masking a problem. And some people want that. Like a lot of people want that. It's both a supply and a demand issue. And that's like one of the caveats that Jack likes to talk about too. In a decentralized system, you have to be willing to take the responsibility for yourself. You literally, like a doctor's not going to do that for you. You can't just trust an expert. You need to become somebody that you can trust. You need to
Right.
inform yourself. You need to be empowered. You need to be cultivating health and then being able to instill that in your children,
Right.
not sending the kids to school to be indoctrinated and to the pediatrician to get jabbed to the gills.
Yeah.
And then it's like you now they have no autonomy essentially. And you don't have any autonomy over them because, at a certain point it can become hard to turn the train around. But also kids are very plastic and able to be adaptable.
Yeah.
So I think the earlier we can start implementing changes, like my 13-year-old stepson at home, like he wears blue blockers every night when he's on his computer. He has red lights in his room. Like he's been on this for like a couple of years now with us. So like it's just normal to him now. And he talks about it with his friends and he's like, my stepmom goes on cool podcasts and stuff. So like it's cool.
Yeah. Yeah, that's all. But it's also, it's like hard. It's everywhere. Like it's hard to escape. Like even my kid goes to school. He's like, oh yeah, we had snack time today. Our teacher gave us Oreos.
Yep. And they're on tablets and like the computers all day now too.
Yeah, they put them on laptops and tablets.
Yeah. There were studies back in the 80s that showed that if you essentially put kids in a room with fluorescent lights and you basically like watch them over the course of the day, they're all fidgeting, they can barely sit still, they all look like they have ADHD. The next day they went in, they filmed for the day, they had artificial lights turned off, they had the windows open, natural light coming in, and they were able to sit still and focus.
Oh yeah. I can tell a stark difference between whether my kid's been inside, like watching TV, versus if he's been outside.
Like behavior
Totally
too.
different kid behavior.
Tantrums and snacking and yes, so much.
100%.
So I mean, we really can clearly see that as parents, and also just at a larger scale. Like this is definitely going on. So what are we going to do about it?
Is it good enough to do the nighttime mode on like the iPads or the phones, where you can do it on nighttime mode where it makes it more amber than it's blue?
I personally keep my phone on amber all day, and at nighttime it should be red, because you really want to eliminate all of that.
I got
light.
this app.
Is it Flux?
Or no, it's not on my phone. I was able to go into the settings and do the color tinting.
That's
so I
what I
got it
do.
like a little bit more red. It's
That's
not
what I
like
do.
totally red, but it's a lot more.
Yeah, I think amber is even better. It like basically turns all blue to green. So you can do that. It's like all the way on the left, almost all the way to the left side of the color filters spectrum.
Yeah.
Yeah, I can show you after, but that's what I like to do for the daytime. And I don't even notice that it's on. It's like barely making a difference because you can still see mostly the high fidelity. It's just basically reducing some of that blue load.
All right, so tell me about the crystals.
Yeah.
Let's see this crystal you got here.
Yeah.
What
So
is this?
this is a Vogel crystal. It's a 13-sided Vogel. Marcel Vogel was he worked for IBM for like 30 years. He worked on engineering the LCD crystal displays, liquid crystal displays, that ultimately developed into like all the screen devices that we have today. But when he retired from IBM, he started working on crystals because, of course, he had worked on them a bit when he was there, but then he continued down the path. And he did these studies to show that if you vortex water around one of these Vogel crystals that's charged up either through putting it in the sun, or you could even charge it up by holding it in your hand, you vortex water around it, it actually creates UV light in water. So you can test the water before, no UV light. You can test it after, UV light.
Wow.
Yeah. So obviously there's implications from that in like water sanitation, of course. Like if you're trying to make potable water that people can drink, the UV light can help to keep the load down of like pathogens. But in addition to that,
Just him, huh?
yeah, that's him. So there's a book called Primary Perceptions by Cleve Baxter. That's a kind of an expose on his work. I'm also taking that class with Robert Gilbert, that we have a whole section on working with Vogel crystals. I'm basically doing some intro research studies with Nicole Shanahan on these crystals to repeat his studies at first, and then we want to kind of expand upon it because the body, like molecule for molecule, is vastly made of water. It's like, I don't know, 80% water or something. The water content dwindles over the course of the aging process, and that's directly related to mitochondrial heteroplasmy and mutation rate, because if your mitochondria aren't functioning as well and they have more mutations, you make less water. And now when you die, let's say you're 90 years old when you die, you could die at like 50% water, 45% water. When you were born, it was like 90% water. So gradually, as that energy and water capability, like the production capability goes down, you start to desiccate and dehydrate. And so water is really instilling life.
Yeah.
But in addition to that, so if we know there's so much water in the body, by extension, if we can vortex water around this crystal to make UV light, the notion is, can we use these crystals in some way to increase UV light availability to the body as well? Either just by holding it or charging it in a certain way or interacting with it in a certain way. And that would help in cases like long COVID or other chronic diseases where it's like very UV light deficient systems. And right now, Jack is basically saying, move into the tropics if you're super sick. But what if we could leverage something like this to allow people living anywhere to get access to this?
Interesting. And what would be the how would you utilize it? Would you just have a room filled with crystals?
So we don't know yet.
Okay.
We got to test it, but we're thinking, half joking was saying that maybe we could like put crystals up your nose because like I have an intranasal red light probe. Not eating them. No, oh my God. That would hurt. Not recommending. But like we have intranasal red light probes because at the top of the nose, like the bone that separates the nasal cavity from the brain is super, super thin. So if you do intranasal red light, you can actually really directly stimulate the brain. Also, of course, you can use a helmet. Specific wavelengths of light, like 8, 10 nanometer light is pretty good at penetrating through bone. But by the same extension, we're thinking...
That's why what people put those red lights... I've seen people put red lights up their noses.
That's it. It helps to get to the brain.
Wow.
So if you have things like neurodegeneration, Parkinson's disease, brain fog from long COVID, things like that, you can directly help to stimulate brain metabolism through the red light exposure to the brain through that very thin bone. But yeah, we got to think about it. We're gonna have to try things. This is like very new research. Nobody else has really done this other than the initial vocal studies. Yep, there it is.
Oh my God.
My God, that's so dorky.
It seems crazy.
That's so dorky.
Yeah, it really. Yeah, and then Jack was saying that a lot of these red light devices flicker like
They
crazy,
do.
and they're really bad for you. Actually,
That's true. Like Juve is really high flicker, high non-native EMF. It just depends how they're designed. Also, in general, red light panels are suboptimal compared to the sun because they are LEDs, and so that means they have very narrow wavelengths. So, like for example, you may get a red light panel that has like 5 or 4 different wavelengths of red and infrared light. When you're out in the sun, it's like you get hundreds because you're getting all the way from like 600 nanometer all the way up through 3100 nanometer and everything in between.
Right.
Versus just like these discrete wavelengths.
Yeah.
So that's one benefit, but also there's like lensing effects from red light panels, which is something that happens when like you have LED lights, and of course they have like those little mirrors behind them to kind of amplify the light.
Yeah.
So it's like the light is being distorted in a certain type of way that's kind of unnatural. So anytime you can get like a DC current light source, such as the sun, and also our bodies run on DC current from the mitochondria, that's not an LED bulb, that's going to be no flicker, because flicker is essentially an artifact of AC power grid.
Yeah.
It's literally you're seeing like the alternating current within the power grid, but DC current is directly powering it, so it's completely stable, no flicker.
And how specifically does the flicker hurt us?
So whenever you're experiencing flicker, the pupil is rapidly expanding and contracting. You may not be able to see it, but it is happening. And even with some lights, you can just put your phone on slow-mo mode and film the light, and you can see it flashing. Some flicker is faster than others, so sometimes you may not be able to pick up on that with the phone.
Yeah, like when you're Steve, like when you're shooting something in a super high frame rate,
Yep.
high speed, and your shutter speed's not correct, you'll see that flicker.
That's it. Yeah.
And how is that bad? So when your pupils are expanding and contracting like super fast?
It's both exhausting to those skeletal muscles that have to do that, but it's also very stimulating to the sympathetic nervous system. So it's that fight or flight branch of the nervous system that gets you kind of hyped up. And we need to get parasympathetic for a decent portion of the day in order to rest, recover, restore, regenerate our tissues. If we're constantly in like low-grade flight or flight state, we're never getting into that recovery state.
Got it.
So there's that. There's also, as it relates...
Juve is the worst. Juve has the worst flicker of all the red light panels.
That's what I've heard, yeah. I haven't tested it myself, that's what I heard.
Right.
So I use MitoRed, and I also use Soleil Well from my friend Kelly Bento, the Quantum Mom on Instagram, and hers are great, and MitoRed is really good.
Yeah.
They like specifically design them with drivers that have no flicker, and where the like driver is also put, it minimizes the EMF exposure while you're using it.
But what if you're using the Juve with the flicker and you're not like looking at it? What if your like eyes are closed or you're like looking the other way?
I don't know. I am kind of ambivalent on that point.
Right.
I think if you can, also Juve is way more expensive than most of these. So
Yeah, they are.
I would say that if you can get something cheaper that's better, then do that.
Yeah, I just got the I haven't got them yet, but I got the EMR Tech ones.
Yeah, I heard pretty good things about those as well.
Yeah, Jack told me to get them, so.
Yeah.
Are you supposed to just bathe in this light for a few minutes, or do you just is it like a source that's always
also-
on in your room?
And also, what is the optimal time to use these red lights?
Yeah, so it would depend on your goals, I would say. For injury recovery, typically you want to position yourself around 8 inches away from the panel, and you want to do about a 20-minute session on the area of concern. If you're just looking to, get some overall benefits, it could be good anytime to use like during the day, essentially when there's red and infrared light outside.
When there's red and infrared light outside.
So
it'd be
from
good-
sun up to sundown, essentially.
So basically, any time during the day, it's good to use.
Yeah, I wouldn't
Okay.
use it at nighttime because at least the red lights on those panels are pretty bright. So bright light and blue light both can inhibit melatonin release from the pineal gland and can impair your sleep quality. Also, relative to light at night, I wanted to make sure I mentioned this. There's a study that shows that sleeping in a room with very low levels of light for a single night, the next day, more insulin resistance, higher levels of blood glucose fasting, lower heart rate variability or HRV, which is a measure of your nervous system
With no light?
with low light.
With low light, you have a lower HRV?
Yeah.
Lower HRV is bad, though, right?
Yeah. You need to sleep in a pitch black room. Even very low levels of light are harming your metabolic function.
Oh, okay. I see what you're saying.
Yeah. So a lot of people will sleep with the TV on or they have night lights on. Like, it's really bad news from a metabolic health standpoint. It's literally creating insulin resistance overnight. And imagine if you do that every day. Now you're literally setting yourself up for having poor metabolic health every single morning.
It's also good to sleep with it cold, right?
Yeah. Yeah, definitely. Because
Zero light and cold temperature.
cold actually helps the semiconductor networks work better. So also, in order to get into good deep sleep, you need to drop your core temperature by like a degree or two.
I've noticed that during the colder months, I typically during the day have just more energy. Or when I'm in a place that's cold, like I'll have more energy during the day. I don't know why that is.
Are you in the cold?
What do you
Or are
mean?
you just there inside?
And like if I'm outside and it's cold out, or if it's just like even if I'm inside, just like in general, when I'm in a colder climate, I typically just have more energy overall.
Yeah, well, cold is very stimulating to mitochondria, which stimulates the production of photons inside of you, the infrared and UV light.
Right.
That's also why cold plunges can be very energizing, and they actually create more dopamine and norepinephrine in the brain, like by far, than Adderall and like the stimulant drugs.
right.
It's very, very stimulating to those
That's
systems.
another crazy thing is how many people are prescribed Adderall.
Yeah, it's wild. And it's so addictive, and it has you build a tolerance so quickly, and we're putting kids on it.
Yeah.
Because they can't sit still for 8 hours, which they never should have to begin with.
I could tell when I have had a few people on this podcast that have been on Adderall, their pupils are just like fully like wide.
Whoa, yeah, that'll do that.
A lot of people take it. It's crazy.
Yeah.
And it destroys your dopamine system.
Absolutely. It will fry you. And it's crazy that if you look at the prescription, like if you get it prescribed by a doctor, it will say to take it every day. And it's like, that's the last thing you should do. You're going to build such a quick tolerance. You're completely frying your dopamine system, and people will feel bad. Like, they usually don't feel good taking it like that until they gradually build up the tolerance, and now suddenly they don't feel as bad. But it's like, what are you doing? Like, what's the cost of doing that? You're really just, and actually that's how I see like all stimulant drugs. People tend to use stimulant drugs to complete tasks that they don't want to do. So if you take a stimulant, you can then do anything and it's interesting, instead of actually following your gut and like what you feel passionate about.
Yeah.
If you're working a job you hate and you take a stimulant, it kind of takes the edge off.
It makes it,
Makes it tolerable.
Exactly. It makes it tolerable.
Yeah. So
That's
it makes
true.
total sense that people are abusing these substances because most people aren't living in alignment with their dreams.
Could that be the same thing though with like with cold plunges? Like if you do them every day, and can you build up a tolerance to where you don't get the same effect of it anymore? Like you don't get that dopamine boost, or you don't get that like euphoric feeling when you get out of a cold plunge?
So there is an adaptation process that occurs in response to cold. That's actually a good thing. So you're, like we mentioned earlier, you're going to build that brown fat and that beige fat that helps to make metabolic heat in response to cold. So the
Which
more
is basically the fat being infused with more mitochondria.
Exactly. And so if you're doing that, you're going to be more cold adapted. So maybe plunging at like 55 degrees feels like nothing anymore. Maybe you want to go down to 45, and that's going to feel more challenging. It really depends on what your goals are, because ultimately the semiconductors that make up your entire body, and what is his name? Albert St. Georgi. He's the one who basically, he won a Nobel Prize, and he gave a talk that Becker was a medical student at the time, and Albert St. Georgi was giving this talk, and he was saying, it's funny, but it seems like life and biology is encoding for semiconductors, that like all of the proteins and enzymes that we see encoded are semiconductive in nature, meaning that they're essentially allowing for the flow of electrons, and like in the same way that semiconductors work in like phones and other devices. And so when Becker heard that, like that really kind of sent him down his entire path of studying like electromagnetism in biology. But if you think about it in that way, we know that like if you're working in like these intense physics labs, they like to do, especially like quantum studies, they'll do these studies at very, very, very low temperatures, because that's actually when the quantum phenomenon can be detected.
Yes.
So by the same token, if you cool the body down, it becomes more efficient as well. So you're getting that benefit kind of regardless of like, let's say the dopamine and norepinephrine response, just by cooling your body down.
Right.
And so there's going to be benefits to that. Obviously, the brown fat as well. Your body's naturally going to sit around like 98 degrees. So even being in 55 degrees water consistently every day, like even if you don't feel as challenged by it, it's still good for you.
Right.
By those mechanisms. If you're looking for the psychological benefits, Tom Seeger talks a lot about this. Like if you're looking for those benefits, you kind of want to push yourself and do it so that it feels challenging to you, and that's going to give you the resilience psychologically. And that's why he recommends doing like if you're especially males, to do like lower 40 or sub 40 temperatures to really get that like that boost psychologically and that resilience.
The sub 40 is crazy.
Yeah. That's where adding the salt helps as well, because if you add salt, that's why you like in the wintertime, if the ground freezes, people sprinkle salt because it lowers the freezing point.
Oh, so the ice won't form so much?
Yes.
Okay.
So you can get it down to like below the freezing point of water. You can go down to like 30 degrees, even though the freezing point is 32 if you add enough salt.
Does
so
the salt screw up the plunge at all? Like when you like for the cleaning of it, or does it affect any of the flow or the cleanliness of it?
It doesn't. You can absorb. You can absorb or dissolve a ton of salt into water. It's like very, very soluble, especially like the Epsom salts as well. For the Morosco, it's really great because you don't have to clean it at all. It's self-cleaning. Really? Yeah.
I heard that I thought you still had to clean it.
No, there's a filter that's in the back portion, like in the mech space. And then there's a little, like a sieve that's inside the bottom of the tub that will collect any sort of like bigger debris. So that's the one thing you just want to kind of wipe off. But other than that, the disinfecting process is literally through ozone.
Okay.
So you don't have to add any chemicals.
Right.
It stays beautiful and pristine, and you have like a skimmer so you can like skim out like any sort of like overt debris. But other than that, like a lot of the other cold plunges, most of them that I've seen, you have to add like chemicals to keep it clean. So this ozonation is just like a real game changer. It makes the maintenance like a breeze. You don't have to do pretty much anything. Yeah.
Yeah.
I love it.
My little freezer that I use, I have to clean it like every week.
Oh, yeah, it's a pain.
Yeah,
you're never gonna have to do that
I'm excited
again.
for the Morosco. I got the tall one, the one that you have to you sit in there.
That's a new one, right?
It's like a box.
Yeah.
I
Oh,
think it's
right.
newer. It's not like the lay down tub.
Got it. Yeah, I have the long one. We have like the XL long boy. Yeah.
Those things are sweet.
They're great. We can fit 2 people, so I'll plunge
Two
with my
people?
friends. Yeah. I plunge with my friend or my partner. It's like fun. That also, as Tom would say, like facilitates bonding.
Oh.
Because when you go into the cold, it stimulates the production of vasopressin and oxytocin, which are 2 of the 3 chemicals that are involved in like bonding between mammals.
Huh.
So if you do that with like a loved one or a friend or whatever, like it helps to build bonding chemicals between you.
Yeah,
which is
there's
pretty
no
cool.
way in hell my wife would ever touch that. She hates cold water.
Really?
Oh, yeah. What about like supplements? Are there any like supplements that you would recommend, or that I know like Jack's like really against supplements and any kind of drugs, but like are there any supplements that are good that there's like no ceiling for as far as like overusing them? That kind of like incorporate all this stuff?
So I would say anything could be overused. I mean, you can even get too much sun at a given point of time. Like everything, you can die from drinking too much water. So like
Right.
everything has its dose response. Regarding supplements, some things that are pretty well tolerated and have good data behind them would be things like creatine.
Yeah.
I would say you're also getting that from the diet. And so it's pretty much akin to that if you're just getting it in
There's
a
like
supplement
supplements
form.
that have these precursors to NAD that supposedly like build like support your endogenous production of NAD. Like
It's silly.
It's silly.
It's silly. Yeah, we did the studies to debunk that actually in my PhD
Really?
lab. Yeah, we
How
showed
so?
that NR and NMN.
Yeah, NMN resveratrol
Yeah.
and TMG.
Yeah, not TMG. TMG is involved in like the methylation pathways, but for the NMN, the NR, nicotinamide riboside, and nicotinamide mononucleotide, we showed that essentially there were no benefits to longevity. There were no benefits to NAD levels outside of tissues. Besides the liver, there was a very small increase in the levels of NAD in that tissue. So when it comes to NAD biology is mitochondrial biology. So if we're trying to take a supplement to subvert our need to optimize our light environment and water magnetism, for example, it's not going to work. Because NAD, essentially what it's doing is there's something called the citric acid cycle or the TCA cycle. That's what allows you to basically take electrons from food and get it into the mitochondrial electron transport chain via NAD. So NAD plus will take on something called a hydride, which is a hydrogen with an extra electron on it. Takes that on, it comes NADH. NADH can go into the electron transport chain and deliver those electrons into that pathway to facilitate the production of ATP and water. So the NAD is really a readout of how well your mitochondria is recycling that NAD, because after the NADH drops off that hydride, then it can go back essentially and take more electrons. So if your mitochondrial function is sluggish, you get a buildup of NADH and a drop in NAD. Taking a supplement to deal with that problem is not actually dealing with the problem. We actually need to get to the root of why are the mitochondria sluggish. Are you having too much deuterium in your diet? You're not getting enough sun? Are you in a lot of blue light? Do you have high heteroplasmy from, whatever, inheritance from a parent or poor lifestyle choices? So those are like the real, if you really want to support NAD metabolism, that's what you need to focus on, not supplementing, because that's just really, and again, putting a patch on a problem that's much deeper.
So like the same thing with people who do intravenous direct NAD.
Yeah, actually, I remember when I brought that up to my boss, Josh Rabinowitz, during my PhD, I was like, hey, people are getting NAD IVs. What do you think about this?
Yeah.
I think it's kind of like a little out there. And he was like, yeah, it doesn't make any sense actually, because there's no transporter for NAD into cells. It's never been identified. So what we think is happening is that NAD is getting cleaved into maybe nicotinamide or another derivative of that in the bloodstream, and then that's getting transported into cells. So there may be a benefit to getting the nicotinamide in for a variety of reasons, but the NAD itself is likely not facilitating that. And it also relates to like when people take niacin, they get that flushing response.
Yeah.
Pretty similar actually to the response that people get when they get the infusion of NAD. So there may be some interconversion or reactions happening that's converting that maybe even into niacin, that's giving you that like paresthesia, it's called, where the pins and needles and like that discomfort that people experience when they get those IV infusions. So it doesn't seem like there's a direct benefit to getting the NAD IV. At least there's no evidence at this point that there's a transporter for that molecule into cells. Yeah.
Have you seen this guy, Bryan Johnson?
Oh, yeah.
What do you think about this guy?
He's the worst ever. He's the worst ever. He literally looks like a vampire.
He looks strange.
He takes his son's blood and puts it into him.
Where's he getting all these ideas
There
from?
were studies in mice showing that if you put young blood into old mice, it makes the old mice younger. Like phenotypically, it makes them act more young and healthier.
That's what he's basing this off
Yeah.
of, and that's why he's taking his son's blood.
Yeah. Yeah. But like, there's no way, like, if you take 100 supplements a day, like, you're completely missing the point. Because when you're getting nutrients from food, it's always in the perfect ratios with other nutrients, with the right macronutrients, like basically telling you information about the season as well, because depending on the season, certain foods are growing, certain ones aren't. So all of that information is being encoded and it's being interpreted by your mitochondria to tell your body what to do with it, essentially.
He does look like a vampire, doesn't he?
Absolutely. It's not even like, no, it's just not good. And he's the one who's been spouting stuff about like no healthy tan, blah, blah, blah. Sun
about
is damaging.
what?
Like the sun is killing you or whatever. You have to
Really?
block it at every turn. Yeah.
I feel like with some people, they just go like way overboard, and there's clearly some sort of like mental disorder
Yes.
going on under this, where you just get so obsessed with something and you'll just do whatever it takes to.
Absolutely. And yet he's still going to die one day.
Yeah,
And we'll
that's
see when,
that's
but-
another interesting thing is like the average lifespan of humans has never really changed.
That's right. Most people will actually refute that and they'll say our ancestors only lived to 30 years old, but not true whatsoever. Actually,
No.
if you look at that, that's when they factor in infant mortality. So I get this pushback a lot, and I'm like, I have to tell this little spiel,
Right.
which is if you take infant mortality out, which we have made improvements on like significantly,
Right.
then you can see the average lifespan is around 70 years plus, maybe up to 77 years, something like this. So we really haven't made headway by way of lifespan, and that just goes to show that our system really isn't working very well at all. We can save people in a pinch in acute care settings. It's
Yeah.
great to have modern medicine. Outside of that, we tried to basically apply the same conditions or the same approaches to the chronic disease context, and it's not working because you can't just we're dealing with systems that are far more complex than we understand. Essentially, you can't just go in and fix one little pathway and not expect a myriad of other effects to happen as a result of that. We're just really looking at it. That's also a byproduct of like the very reductionist, like the scientific reductionist view of looking at the world, where we're just looking at single pathways and single reactions, and then we think we can just modulate that one without any repercussions, but it's just not how biology works.
Right.
Yeah.
Yeah, it's interesting. Like even back before we had all this technology and all this radiation and all these EMFs and blue light everywhere, that we were still living the same lifespan. Although now there's obviously way more cancer.
Oh, yeah. All
Right. There's way
chronic
more
diseases in general, all the
Yeah.
cardiovascular disease,
Yep.
cancers, neurodegeneration. Most cancers were unheard of in the
Right.
even the early 1900s. So I think we mentioned that earlier. So it's like something's not right. We need to address the elephant in the room.
If there was a way to make human beings live longer, what would it be?
Well, it would be leveraging mitochondrial medicine, because Doug Wallace literally showed in his lab that as you age, you accumulate mitochondrial heteroplasmy, those mutations in the mitochondria.
The water and the mitochondria.
The water and the ATP are not being made as efficiently because of those mutations. And if you look at people with chronic disease, even if they're younger, they also have higher mutation burden. Their tissues look older. So in essence, if you can leverage mitophagy and mitobiogenesis to reduce heteroplasmy, to purify your mitocolonies, you're essentially reverse aging. So if you can do that in a really efficient way, then you can actually extend lifespan, because lifespan is essentially you reach a critical point at some point where you're not making enough energy and water to sustain your
Right.
tissue function from those mitochondria. So if there's a way to reduce heteroplasmy in such a way that it's like not hacking the system, but working with the biology that's present, then we could potentially do that.
Have you ever heard of the guy, the physician, the classical physician named Galen?
I don't think so.
He was Marcus Aurelius's physician,
Okay.
the Marcus Aurelius, the emperor. And he developed this medicine, which was like a panacea. People thought of it as like a panacea for everything. It was called the theriac.
Okay.
And it had like 100 different ingredients in it, from like viper flesh, North African viper venom, honey, cinnamon, all different kinds of things. And he also was using, basically a lot of people, I guess, in antiquity died from snake bites, from like venom from snakes, like especially like North Africa and that part of the world in Europe. And what he would do was he would take children, younger people, and he would cut them in a part of their body, like their arm or something like that, and wrap a bandage, soak it in viper venom or the snake venom or whatever. And he would like wrap the cut in the venom where it was only a little bit, enough not to kill them. So I guess like they would somehow build antibodies, and they would use that person's bodily fluids as an antidote to these snake bites. So they were like using antibodies, I guess. Like some of the stuff that he was doing was like bizarre. And it's just like, you know, I wonder why or if or how much people like pay attention to that sort of like ancient medicine that these people were doing back in the day. Like this weird sort of like fringe kind of sick stuff that they were doing.
Yeah. Well, I mean, most of what you just said there just sounds like leveraging hormesis in general. Hormesis being like that notion that what doesn't kill you makes you stronger. Cold is hormesis, like hormetic stressor, exercise is, dietary restriction, fasting is, certain specific molecules can also be. So metformin's not a great example of this, but essentially the way metformin was found was that there were these goats in France that were eating like rue lilies or something, some specific type of French lily in France, and they were living longer than the other goats. And then they basically, you know, went in and tried to figure out what was creating that effect, and they synthesized metformin from those lilies. And actually, like, I think 80-something% of like the pharmacopoeia that modern medicine uses derived from some sort of plants. But anyway, that's just to say that like there are a time and place for these things. Metformin is kind of a can of worms though, because metformin use actually prevents you from gaining positive adaptations to exercise, and it actually impairs mitochondrial function. So metformin shuts down complex 1 of the electron transport chain. Not completely, but it poisons it slightly. So that's used, in essence, they use it in diabetes to basically help make the cells think that they've eaten more than they have, essentially, because now you're building up NADH, which is associated with like a fed state.
Right.
But you're also like low grade poisoning those mitochondria. So that in combination with the lack of adaptation to exercise on people using metformin, that's like a major red flag that this is not a good thing to use. But there's also a caveat here, which is that there's no light controls in any of the research that we do clinically or in rodents. So actually, I have a story that I like to tell. When I was doing my PhD at Princeton, I was doing some circadian studies, and I was there at like midnight, and I went to the mouse room. And I went in the mouse room, and I could only put on red lights because we knew that if you put on the bright lights, it could throw off their circadian rhythm. It could affect their metabolism. So I went in, did what I had to do, went back to the lab, being blasted by fluorescent lights to do what, you know, do my experiment or whatever. And at the time, I was just like living in the like hypocrisy, let's say. I didn't recognize it as it was. But after the fact, I'm looking back, and it's like, how can we recognize that like bright white lights at night are negatively impacting, you know, metabolism and changing things in the rodents, but then we're made to work under these conditions where it's like completely inhumane in some ways. So I think there's just a lot of cognitive dissonance in the standard like centralized science and model. Like the people aren't connecting the dots that, you know, we are animals too. We have certain inputs that are required for health, and those inputs aren't being acknowledged, and to the point where we literally don't even have controls for our experiments, because on one hand, if we're studying everybody under artificial light all the time, that actually is a good representation of the population, because most people are, but we're not actually understanding fundamental biology, because if we looked at them in a natural environment under natural light, we may see completely different phenomena. We just don't have that data, and that's, again, why I want to start my decentralized light lab, to be able to ask these questions and revisit a lot of the cornerstone studies in the proper light environments, and we can see what happens under those conditions, because it could be entirely different.
It's also crazy that they do surgeries under those giant LED lights. They shine them right inside your body.
Right.
Or like in Jack's case, on their brain.
Yes, it is. It's incredible that he never got sued once, and it makes complete sense when you learn about like how he was doing things differently.
Yeah, with shining the red lights in the rooms when
and
he
the
was
peroxide
doing the
and the UV light.
Peroxide, the methylene
blue. Yeah. It's incredible.
There was something else on that podcast with Huberman and Rick Rubin where they were talking about one of Huberman's colleagues, I think at Stanford, who's a brain surgeon or a neuro something, brain guy. And he said that 50% of the medical literature is like complete bullshit.
Yeah, I remember this. I'm trying to remember his name, but
I can't remember why he said it was bullshit. If it was like corrupted or if it was just incorrect or out of date, maybe.
Yeah, either way. I mean, there was even a study out a couple of years ago showing that 80% of the recent medical literature is not reproducible. meaning other labs can't get the same results as
Really?
the initial labs did. Yeah. So, I mean, that's also not surprising if we don't have light controls, because maybe they had different lights in different labs. That could also have a direct impact on the results they're getting. We're just kind of aloof. That's like part of the unknown unknowns for most researchers.
Right. What do some of your colleagues, like from your school, talk? Do they like? How do they respond to some of the stuff you're talking about? Or are they open-minded about it? Are they?
I haven't gone back and talked to my old bosses about it, but when I first found all of this stuff, I was in my postdoc and I was bouncing it off of my boss at the time. And he, like I said, he was like, oh yeah, the alpha MSH connection makes complete sense. Like I didn't know any of this. So he was like really curious about it. But I never like followed up on that. And I think he's actually going to Stanford now. He got like a big offer to move over there. So he's not going to be at Penn much longer. But yeah, I don't know. I've been taking Jack's advice, which was Becker's advice to him, to not just go blabbing around to everybody about it, because, I mean, best case, I guess, would be getting scooped, because I actually don't mind. If they want to go do the research, they can do it. I don't need to be the one to do it. I just have to be the one to do it now because nobody else is doing it. But worst case, they could try to sabotage my career or something else. So, like, I've just been kind of operating more in the background, just trying to figure things out and doing some of these initial studies with Nicole, and then just trying to fund something that's going to make me completely independent from an institution. Like, I don't want to have to be associated with that, because if you look at most PIs, which are like the heads of labs at these big academic institutions, they spend like 80% of their time writing grants from the to get money from the 3-letter agencies. They're not spending any of their time mentoring students, making sure things are being done right, learning new things themselves. They're really just focused on getting more funding. They're on this hamster wheel of like, I just need more money, more money, more money.
Yeah.
And then you're only able to get money for certain types of projects because those are the ones being prioritized by the CDC, FDA, whatever, NIH, et cetera. So if there's only certain projects being funded, then you're going to tailor your research to be able to fit within those paradigms. And now maybe you're not focused on the thing you're interested in. You're just focused on the thing you can get money for. And that's just the rub in the centralized model, because they don't even think out of the box, like other ways to get funding. For example, I was at this like conference for bioelectricity like 3 weeks ago. It was online. And Michael Levin was presenting there. He's kind of Becker's protege in a certain sense.
Michael Levin?
Yeah, he's at Tufts University, and he's really one of the only people successfully studying bioelectricity right now, like Becker was, but he's doing it a little bit more low key. And I was a bit of an antagonist in like the Zoom chat. I was like, hey, like what are the effects of non-native EMFs on these systems you're studying? And he kind of gave a very non-committal answer. It was just basically like, I don't know if it matters, but like obviously it should matter because this is an electromagnetic input into an electric system. Like why wouldn't it matter? So I don't think he's focusing on questions like that because, again, he's not going to get funded, or it's inconvenient, or it could get him targeted or canceled like Becker. And then at the end of that conference, there were like 10 of the PIs were griping about there not being enough funding for their projects. Like they could never get money, and it's just they can't do the research they want to do. And it's just that's the rub in that system. You can't really get around it because that's the model that's been built. You kind of have to go outside if you want to get stuff done. And most of them are too scared and blue light toxic to do anything about it because they can't even see out of the box. Because when you're in a sympathetic state from all this blue light and from, being in the rat race, you literally can't even see the bigger picture because sympathetic drive shuts off your peripheral vision literally. So like you can't see as much of your peripheral vision, but it also shuts off your ability to see the bigger picture and see peripherally in your mind as well. It's really, you're just focused on survival moment to moment. So I think that's another aspect to this that's really important, is that this technology, these environments are literally shaping the way we think and feel and the way that we perceive life and reality at a very fundamental level. It's hijacking wiring that's supposed to be, in response to the sun, where we get this balanced spectrum. But instead, it's very isolated blue that's hijacking these pathways, that's preventing us from actually seeing reality as it is at a certain level.
Yeah, no, it makes a lot of sense. Just like with capitalism and how it's like it's the worst part of capitalism is the way it's utilized with pharmaceutical companies and with these schools, and it's like you're trying to like focusing on money versus like the health outcomes of the people is going to get you the opposite effect. And then once you get so far down the road, like you kind of like lose sight of what the goal was in the first place, which was to make people healthy, and now you're just trying to survive and earn more money and increase salaries and climb the ladder of whatever company or whatever federal FDA or EPA agency you work for. And it's, like you said, it's just a rat race.
Yeah, I mean,
I don't know how it could get back. I don't know, like, I mean, I know other countries like in Europe that have socialized medicine are generally healthier. I know that some of like the grocery stores have much healthier foods in there because they're incentivized to keep people healthier. Oh yeah. Because it costs, they don't operate the same way we do.
Oh yeah. I mean, there's way less like, let's say, toxins permitted on their foods in Europe. Like they're much more stringent compared to our FDA here. And there's kind of like a big ruckus about that here. I think there was some petition to Kellogg's to take all this BS out of the food, like the dyes and the preservatives and stuff that's not present in other countries. So there's that.
Canada too, right? Is Canada like that?
I think Canada's even better than us for sure. It's pretty insane how they can get away with that here. I mean, I think that just points also to the financial incentives in place for, these people to be able to do whatever they want essentially to our food supply and our environments.
How do you fix it?
I mean, awareness is the first thing, because if people don't know there's a problem, then they're not going to look for a solution, and they're not going to be able to make better choices for their families and themselves.
Yeah.
And I think people are building awareness around this. There's a lot of like rhetoric around this online, around, health in general and nutrition, but I really think we need to focus an equal amount at least on the light part, because that's really the missing piece that people aren't recognizing, that's driving their cravings, that's driving their inability to say no to things, that is also driving drug abuse and alcohol abuse and other things like that, because you're just constantly looking for that next dopamine hit like we talked about earlier.
Right.
So once you get off that dopamine wheel, you can actually kind of like pop up above the water and you can kind of see what's going on. And you can make a clear-headed decision versus just constantly compulsively going from one thing to the next, like just surviving essentially, like we said before.
Yeah. Well, that was amazing. Thank you. That was 3 hours.
Was it?
Yeah.
Oh my God. It was 3 hours.
Tell people that are listening and watching where they can follow you and listen to your podcast and all that fun stuff.
Yeah. So I'm on Instagram at Dr. Alexis Jasmine, JAZMYN. And my podcast is called Undoctrinate Yourself. It's on Spotify and YouTube right now, but it's going to be on all platforms pretty soon. That's where I'm most active. I have a live course that's starting tomorrow, actually. That's like a protocols-based course for a whole bunch of different things, from fat loss and muscle health to metabolic health and mitochondrial function and long COVID and things like that. And I try to teach as much as I can. I used to take a lot of one-on-ones. I'm mostly teaching in group settings now. I'm putting a lot of free content out on my podcast and on my Instagram, and I'm becoming more active on X as well, which is the same handle as Instagram. So that's where people can find me.
Sweet.
And yeah, there's like literally a treasure trove for anybody who's new to this space. Like if you just go on my Instagram, you can learn for hours, and on the podcast as well. I've had 3 episodes with Jack, and a bunch of other incredible guests as well. Like lots to learn about. Oh my God, the Kamala Harris book.
Did you read that?
Cover to cover.
How was it?
It's blank.
Oh my God, that's hilarious.
I know. It was a #1 bestseller on Amazon.
This book is unburdened by what has been. Wow. That's amazing. That's awesome. Well, thank you again. I really appreciate it.
You're welcome.
I'll link all your stuff below so people can go check it out.
Great. Sounds good.
All right. Good night, folks.